Hello.
Hello.
How are you?
Fine.
Perfect. My dear friends, we start section 1 in second day. I'm glad to see you here, all of you, and this is very good that you come to our conference. I'm inviting questions in YouTube and also in chat in Zoom, and you after each presentation you can ask some questions, find new contacts, new collaboration for your future studies. And the first, I'm sorry, I'm announced first presentation, but we still waiting 1 or 2 minutes. First presentation, it's Maxim Dembowski, development of biotechnical magneto. Sorry. 2 minutes, please. Development of a biotechnical magnetoplasmography system for monitoring respiratory rate and heart rate. Maxim, are you here? Are you ready to start your presentation?
Hello.
Hello.
I think it's a problem with
Are you ready to start?
your sound is duplicated and it's problem, but we're ready to start. Your sound is duplicated and it's problem.
Okay, and now this is normal. My sound is normal now. Is my sound normal now? Excuse me.
Yeah.
Okay.
Okay.
Good. Let's start. Start your share your screen, please, and start presentation.
1 second. Okay, I'm ready.
Okay, let's start, please. Share your screen.
Okay. You see my presentation?
Yes.
Okay. Let's go. Good morning, ladies and gentlemen. My name is Maxim. And before speaking, I want to ask the section presenter to duplicate questions to the chat, please. And now I give the floor to Svetlana.
So my name is Svetlana. Today we would like to present our development of a biotechnical magnetoplasmography system for monitoring respiratory rate and heart rate. Next slide, please. First, let's talk a little more about sleep-breathing disorders. One of the most common cases is sleep apnea. Actually, the sleep apnea can be obstructive, central, or complex, but obstructive sleep apnea is the most studied form of sleep respiratory disorders. The classification of a sleep apnea severity you can see on the slide. It's generally accepted that apnea is complete cessation of the airflow that lasts more than 20 seconds. So the illustration is also on the slide. The mechanism of development of the obstructive sleep apnea is as follows. The throat is formed by muscles. During sleep, the tonus of these muscles declines. The presence of certain factors, for example, obesity, can lead to a narrowing of the throat with significant difficulty in the passage of air into the lungs when breathing, usually accompanied by snoring. Up to certain limits, the throat muscles are able to prevent the throat from collapsing. But when construction becomes critical, the attempt to inhale cases the upper airways to close completely and respiratory rest during sleep. Next slide, please. The prevalence of this pathology in the population is also given on the slide. Second, let's review the main diagnostic methods for detecting sleep disorders. You can see it on the slide. There are polysomnography and respiratory polography. After analyzing the advantages and disadvantages of these methods, it's possible to conclude that the method of magnetoplethysmography is advantageously different. It's easy to use, cheaper, and can be used not only in the clinic but also at home. Next slide, please. And now let's discuss the method of magnetoplethysmography in greater detail. In a study, this method was used to estimate a pulse blood shape and pulse wave velocity. The proposed transducer consists of a Hall sensor and a permanent magnet. Two different transducers are located above the carotid artery, as shown in the figure. The volumetric changes caused by the blood flow through the carotid artery change the magnetic field. The Hall sensor detects the oscillation of this field and generates voltage in the form as a pulse wave. The recorded pulse wave is shown on the next figure. Next slide, please. So we suggest that this method could also be used to assess respiratory waves. The essence is the same. A permanent magnet of the optimal size is placed on the membrane on the patient's chest above the heart muscles. As a result of breathing movements, small linear movements of the skin area on the magnet occur. Consequently, there is a change in the magnetic field around the stationary Hall sensor located in a parallel plane directly above the magnet. It generates a voltage signal of the same form as the respiratory wave signal, which is subsequently transmitted to a personal computer, processed and visualized. Also, on the slide, you can see intended type of transducers and their mountings. To increase awareness of this particular method, two transducers are used to record the thoracic and abdominal types of breathing. Next slide, please. Initially, the sensitivity of the Hall sensor in the property direction A was investigated, but on this slide you can see the direction of movement of the magnetic relative to the Hall sensor and experiment equipment. Next slide, please. Yes, and now you can see that sensitivity of the Hall sensor in the property direction A was investigated. You can see that in a range of displacement from 4 millimeters and up to 12 millimeters, the voltage is not very different. So we can see that it is an area of optimal displacement values. The 11 millimeters value was chosen as it also necessary to take into account of the ergonomic equipments to the transducers themselves. The displacement of the magnet at this distance from the Hall sensor in the plane was also investigated. You can see that the voltages which was generated at Hall sensor are not very different from each other. This can avoid the equipment to position the magnet relative to the Hall sensor. Next slide, please. The sensitivity was calculated for different magnets in the property direction. Magnet number 2 can be considered the best. Perform a test of the sensitivity for the magnetic gain depending on the deflection in plane. So it does not change very much, and this magnet can be used. Next slide, please. So now let's talk about the result. To visualize the signal, the software Python environment was implemented to find the breeze frame in the signal. It was decided to create an algorithm for the automatic detection of local peaks. The design elements were printed on the 3D printer, and prototype's layout is shown on the slide. Next slide, please. After development of the layout, the product was tested in the resting state, and also sleep monitoring was performed. One transducer was attached using the step provided in the design to the patient chest in the heart area, and the other to abdomen, as shown on the slide. Next slide, please. Measurements were taken in resting state for testing the system performance. In the figures at left is shown the result of measurements without holding the breath. In the figure at the right, with holding the breath, wherein on the second graph from the chest surface, the heart rate is clearly visible. The red and green dots on the graph is automatically spaced by algorithm, indicate the found maxima and minima respectively. As you can see, the obtained frequency is fully consistent with the pre-calculated data. So the signal from two surfaces are similar, so system works properly. Next slide, please. The sleep monitoring was performed on a healthy patient at home. After reviewing and analyzing the recorded data, several breath holds were detected. We can see one episode in the interval from 80 to 95 seconds, in which the amplitude of oscillation visibly decreased. So the result of nocturnal monitoring allowed us to hypothesize that the recorded episode of respiratory arrest can be interpreted as sleep apnea. So let's recap. First, the product is capable of recording respiratory wave signal in different states of subject. Second, the product can detect apnea episodes, but to prove this hypothesis, a study in Somnology Center is required. Third, the algorithm of automatic counting of the respiratory rate showed satisfactory results. Next slide, please. So that's all. Thank you for your attention.
Okay, thank you. Thank you very much. It's a perfect presentation. It's very interesting topics. Dear friends, do we have some questions about these topics, about studies? Okay, one question from me. How do you verify your approach? Do you try to compare results with some other technique?
Okay, I try to answer 1 second. Of course, there are also other diagnostic methods, for example, polysomnography, but I have a short answer. At the moment, this problem remains relevant, and in this stage, and it's at this stage of development. And about accuracy, other methods, our methods require to research with some knowledge methods. That's my answer.
Okay, Thank you very much. We go to the following presentation. It's presentation of Timofey Sergeyev, research of system for monitoring the position of the cervical spine.
Hello.
Hello.
I will represent our presentation without Timothy.
Okay, thank you. Could you increase increase volume of your speech?
Oh, okay. I'm sorry. Are you hear me?
A little bit better, but maybe more better.
Okay. I try. And now?
Okay, let's start. I suppose it's not so important.
I'm sorry.
And we write questions for the following presentation from previous speaker. I try to raise some discussion, some
I see my presentation.
yes, but Zoom close some part of your screen. Could you reduce size of the right panel on your screen?
One moment.
Maybe you have some button in the top of this panel and you could make it smaller. Oh, good. Thank you.
Okay, I understand. So, good morning, dear listening. My name is Danilova Anastasia Sergeyevna, and I represent the St. Petersburg University of Aerospace Instrumentation. The topic of my report is research of system for monitoring the position of the cervical spine. The human cervical region is one of the most important parts of the spine. It is this part of the spinal column that is responsible for blood circulation and the delivery of all nutrients to the brain. Displacement of any of the C1, C7 vertebrae cervical spine will affect the functioning of the brain. In the absence of proper blood supply and outflow of blood, the brain will work with impairment. To prevent such pathologies, the timely diagnosis and prevention, it is necessary to monitor the state of the cervical spine, which include the following studies. First of all, it's the position of the vertebrae of the cervical spine in static and dynamics. Second, the state of the vertebral artery and various slots on the cervical spine. And second, and last, muscle condition. When creating a system, it is necessary to pay attention to the following parameters. The system should be wearable with the ability of the attach to the patient neck, wirelessly, compact and lightweight, and it is also important that the data collection takes place in all directions or three-dimensional. The purpose of this study was to familiarize with existing model system for determining the position of the cervical spine. For this, an analysis of scientific article and patent was carried out. The first stage was meta-analysis of data from open access for articles at Scopus, Web of Science, and CBI, and others. Keywords: cervical spine, movement of the vertebrae, movement of the spine, and sensors. At the next slide, number 4 to 6, you can see the existing system for monitoring the position of the cervical spine. At slide 4, figure 1, show the system. Also, Hamau 2017 from France for studying the influence of the mobility of the tonic muscles of the cervical spine during the transition from a sitting position to a standing position. The next figure show a system, also Duke 2014 from Switzerland, which dedicate to the creation of a variable inertial system for assessing the mobility of the cervical spine. At the next slide, at figure 3, you can see a system aus Minsheng 2019 from China for measuring movements of the cervical spine using an optical motion capture system. At figure 4, you can see a system aus Annemann 2000 from Zurich, the system for examining the total range of motion of the cervical spine. And at the last slide of articles and publication, you can see two figures. Figure 5 shows a system also Robin Neville 2013 from Canada for examining difference in neck position and muscle activity in the inverted position. And the last figure shows a system also Yang Hang 2013 from China for reproducing human biomechanical behavior during rotation traction manipulation. So based on the results of the search for article for the open access of foreign and Russian database from 2000 to 2020, it can be concluded that today there are no systems that meet the criteria of our study, and the closest analog in the system present in figure 6. The second stage was a patent search. Our search criteria was date of patent publication, scope, mobility, accuracy, availability of external sources, availability of sensors in Russian and foreign base. Also, the patent didn't provide a graphical illustration of the system, but the analogs were found. The closest in some evaluation criteria are patent 1, 2, and 3. The first patent calculates the angular coordinates of a point object. Patent 2 deal with the device for assessing the mobility of the cervical spine, and the third patent describes a method diagnostic of osteochondrosis of the cervical spine. The advantages and disadvantages of the considered technical solution are as follows. Advantages. In the patent list above, the main advantages is the possibility of creating a wearable system that measures the angles of inclination of the cervical spine at various positions. And disadvantages. A significant drawback of patent is the impossibility of calculating the state of the vertebral structure, namely the position of the cervical vertebrae at different position of the head relative to each other. In existing patent, there is no description of the possibility to measure the measurement parameters of the data in the cervical spine with full rotation of the head 330 degrees. Thus, when creating a system for monitoring the position of the cervical spine, it's necessary to pay attention of our parameters. The system must be wearable, without wires, compact and lightweight, and have the data is taken in all directions, to forward, backward, to right, left, turn forward, backward, right, left, and head rotation on the axis. Existing system don't meet all of the above criteria. If we talk about articles, in figure 1, 4, and 5, the system is not portable with a large number of wires. And in figure 2, 3, and 6, the system captures data only in certain position of the subject. So the purpose of user research will be to develop a system in which the previously described shortcomings should be eliminated. Thank you for your attention.
Thank you very much. Are you test your system on real patients?
No, it's our first step. When we do only meta-analysis data of open access.
Okay, thank you. Questions, please, from our colleagues. Okay, thank you very much for your presentation. It's interesting, but we hope to see more results in the future because
Yes,
scientific
yes.
conference. We are waiting to look something original, something new in this field of studies. Okay, and the next presentation is Alexey Anisimov research method of human cardiovascular, respiratory, and nervous reaction complex in response to dynamic postural.
I will be.
Okay, good. Let's start.
Give me 2 seconds. Can you see me?
Yes.
Okay. Can you see the presentation?
Yes.
Hello, dear colleagues and participants of the conference. My name is Sergey Forlan. I am one of the co-authors of this article outline called Research Method of Human Cardiovascular, Respiratory, and Nervous Reaction. Reaction complex in response to dynamic postural loads. First, let me explain what we mean by postural loads. Postural loads is dynamic orientation-dependent motion that is applied to human body by using tilt table with distal fixation of lower limbs and sometimes, in some cases, upper limbs. Postural loads application in studies can be divided in several tasks. One of the first one is exploration of physiological reactions in response to postural loads. Then postural laws, how to use postural laws as functional tests. And the last one is postural laws advantages in treatment, in medical treatment. It needs to mention that postural laws can be different and different types of postural laws. We are studying two main types of postural laws. It is orthostatic and anti-orthostatic monophase postural laws that lead to substantial blood redistribution and can attenuate hemodynamic reactions. But there is opposite cases when dynamic postural laws allow to express this reaction to a higher degree. Here on the picture, an example of postural laws on a tilting table. What is a research objective? It is to assess the complex physiological reactions in human body that can be developed in response to postural loads. The task of the research is to create a unique research method to synchronously register and study cardiovascular, neuronal, and respiratory physiological parameters of body position changes which are applied. at the same time. The main points of the developing method is one functional test is to construct functional tests as a methodological basis, then how to perform a constant dynamic passive postural loads. Then we can move to a number of registers and calculated physiological parameters, how to properly gather them, how to achieve criteria on including and excluding study participants, what is hardware requirements for registration of mentioned physiological parameters, then to have an example of the respective hardware software complex to make a good study design. Then it needs to be clear what methods used in processing and analysis of physiological data. And finally, at the end of these studies, complex postural load model and protocols needs to be formed. What devices and study parameters are used here at this table presented several devices. One of those is EEG device of company Diamant company produced. Then there's spirocardioarrhythmograph electroencephalographic complex. Oh, sorry, I'm mistaken. The first one was electrocardiogram. Then spirocardioarrhythmograph electroencephalographic complex and mass spectrometer. All of these devices can measure different types of physiological parameter data, and they can be complemented to each other. To find the frequencies at which they can be correlated. Here the scheme for preliminary scheme that represents how the research is created. First, here the subject, human subject, from which we gather several types of information with the help of EEG, spiroarteriocardioarrhythmograph, and impedance phlebography, or just rheography. All of it connected to different computers. Then data that is recorded on these computers can be dumped to one personal computer where it is undergoing further analysis. Then after that, the researcher analyzes this data, and then according to this data, researcher can regulate the tilting table, the tilting angle, to cause some kind of response from the subject, which then affects his physiological parameters. This is, as I said before, a preliminary study. there is a notion in the future that this scheme can be automatized. Now the application of the method, what was the participants that were in this study is 30 mostly healthy volunteers aged between 22 to 26 years old, and the results from them was this. They expressed increased systemic blood flow, intensified local blood flow in internal organs, and amplification of transcapillary fluid shift. Heart rate and blood pressure did not have statistically significant changes during these postural loads. On the right side, a picture of gathered synchronous, gathered examples in several number of recorded signals from one participant. So main points of this study is the designed research method is purpose to explore how complex dynamic postural loads can impact the human body. It also took into account a multitude of factors that include description of registered physiological parameters and what evaluation and the types of evaluation means. Current method gives an advantage in studying continuously complex of mentioned physiological reactions and creating practical, maybe in future clinical recommendations of correction of human body condition on the basis of this postural influence, and obtained results can fundamentally develop a new way of functional diagnostics, professional selection, and components of non-medical treatment. For example, the rehabilitation of patients with continuous hypokinesia and for people that are professionally engaged in extreme activities. And that's all. Thanks for attention.
Thank you. Dear colleagues, questions for speaker, please. Okay, one question from me and one recommendation. First, in Ural Federal University, Anton Dolganov worked on such kind of data, and I sent a link to his research gate and this publication in chat in Zoom. And I suppose if we connect with them and with his group, you can find more interesting view about how to process this data and what to do. Yes, and
thanks.
And one question from me: why you? What's length of data do you use? What length of ECG and other signals do you use in study? Do you measure it in some position of this device, or it measures continually, and you have information about slow changes in time?
Well, we experiment with different kinds of different kinds of registration. Yeah, as you mentioned, there's a continuous recording of this data. The average length, well, it varies between 3 minutes to 5 minutes. So we think that is the optimal length for the needed results.
Okay, thank you. Interesting approach and interesting studies. The next presentation is Sergei Kast, an algorithm for determination of terrain type in lower limb prosthetic control.
Okay, it's me.
Okay, let's start. Also, dear friends, after the end of this blogging section, we have keynote speaker. Keynote speaker will present his results and his studies in the second section, and in chat and in YouTube, I add link to the translation of the second section. Also, I encourage you to start discussion after finish of this blog. We have some times, about 50 minutes, and we can discuss and help each other with some ideas, some studies. And I suppose it's very important to have real coffee break, real discussion, say your opinion about work of other group, and it's very important to exchange ideas. Okay, let's start, please. Thank you very much. We see your presentation. Let's start.
Okay. Good afternoon, dear participants of the conference. My name is Sergei Kust, and the topic of my report is an algorithm for determination of terrain type of the lower limb prosthesis control. Identification of the terrain over which movement occurs is an important task in lower limb prosthesis. Many types of sensors built in knee prosthesis are used usually to solve this problem. However, some sensors have disadvantages which limit acquiring of them in end product. Sensors are divided into proprioceptive and exteroceptive sensors. Proprioceptive sensors measure characteristics not related to the external environment, such as orientation of the joints and internal physical characteristics of the object. Electromyographic sensors, capacitive and mechanical sensors are classified as proprioceptive sensors. Non-invasive EMG sensors, electrodes, are widely used to collect EMG signals. They evaluate the skeletal muscle tissue activity by recording the biological potential. The EMG biological signal generated by leg muscles can be used to determine the type of terrain over which the object is moving. In capacitive sensors, one transmitter and several receiver electrodes are mounted on special plastic tape. The tape is worn around the limb. The impedance between the transmitter and the receiver changes if the capacity of material between electrodes changes. Mechanical sensors measure the kinematics of the human body and the features of interaction between body and the environment. Exteroceptive sensors, they provide information about external environment in which prosthesis user locates. For example, information about distance to the obstacle and the structure of the environment. Distance sensors and depth sensors are used as exteroceptive sensors. Distance sensors can be optical or ultrasonic. Optical sensors usually use infrared wavelengths. Depth sensors are widely used in terrain detection systems. They are cheap, compact, and resistant to many distorting factors. When developing the control system of the prosthesis, it's important to consider all necessary requirements for the final version of the device, as well as conditions in which the prosthesis will function. The use of exteroceptive sensors violates the requirement for the prosthesis, according to which, for aesthetic purposes, the prosthesis should be covered with clothes. In this case, the distance and depth sensors will not be able to function properly. Capacitive sensors for impedance measurements cannot be used for several reasons. First, the size of the measurement system is greatly increased by using of additional equipment to secure electrodes. And secondly, when using capacitive sensors, it's necessary to probe the limb with electrical current. But the use of EMG sensors makes it possible to determine what movement the prosthesis user intends to perform. EMG sensors do not use probing current, and they can be also quite small. Different parameters of the EMG signal recorded from different muscles of the patient can be used to develop the algorithm for controlling the knee module in artificial lab. It was suggested that it's possible to determine terrain type using electromyographic sensors which record signals from certain muscles. To confirm this statement, the study was conducted. The study involved 6,000 people. The EMG signal was recorded from various muscles of the subject's lower limbs. Each subject performed 5 types of movements: straight movement, ascending and descending on stairs, and ascending and descending on slopes. The electrode systems, composed from 2 weakly polarized electrodes, were attached to the muscles of the right leg: rectus femoris, vastus medialis, vastus lateralis, biceps femoris, semitendinosus, and semimembranosus of the femur. The reference electrode was placed to the ankle to prevent interaction of other muscles and to ensure its minimum effect on the measuring electrodes. Round weakly polarized silver chloride electrodes were selected. The signal from the electrodes was transmitted to the recording unit numbered by 1, and then it was transmitted to the STM32 microcontroller select numbered by 2 with the help of SPI interface. Then the digital signal was transmitted with the help of UART to a personal computer. Next, the signal was filtered by digital high-pass filter with a cutoff frequency of 20 Hz and bandstop filter with a central frequency of 50 Hz to remove network interference. The sampling rate of signal was 1000 Hz. Each signal was divided in accordance with the movement cycles. For each cycle, the parameters of EMG signals were calculated: the mean absolute value, waveform length, RMS, median frequency, mean frequency, and their crossing rate. The mean values of each parameter of muscles of each test subject were calculated. On this slide, the recorded signal from vastus medialis during stair climbing is presented. Parameters of signals with signal-to-noise ratio less than 10 decibels were not calculated because they cannot be reliably isolated from the signal. The analysis of EMG signal parameters of all test subjects show that it's possible to compose the algorithm for determining the type of terrain on which movement occurs by using certain signal parameters for the specific muscles. For all test subjects, the mean value of the median frequency of rectus femoris is different while moving on stairs compared with other types of movement. With help of a mean absolute value of vastus lateralis, it's possible to determine whether the person is moving up or down the stairs. For the semimembranosus, the zero crossing rate is different for straight movement and movement on inclined surface. With help of RMS for the vastus medialis, it's possible to determine whether the person is moving up or down the slope. Other combination of muscles and parameters of EMG signal either didn't show difference between terrains or the signal to noise ratio was less than 10 decibels. According to obtained results, the algorithm of determination of terrain on which fastidious user moves is proposed. In addition to EMG sensors, the gyroscopes should be used both for recognizing the type of terrain or type of movement and for providing feedback. If one gyroscope is placed on the subject's hip in the area of biceps femoris and the other on the prosthetic device, then the angle in the knee joint can be controlled. Values from gyroscopes, as well as values from EMG sensors, are continuously read and fed to the prosthetic controller. If the value from the femoris gyroscope exceeds the threshold level, then the check is performed for the type of movement on stairs or on the inclined surface. Using the median frequency of the rectus femoris, it's checked if movement occurs on stairs. If the statement is correct, then the direction of movement along the stairs is determined by the mean absolute value of the vastus lateralis. If there is no movement on stairs, Then the 0% weight parameter of semimembranous muscle is considered, which determines the type of movement, straight movement or along the inclined surface. If movement along the inclined surface is defined, then the RMS of vastus medialis is considered, which determines the direction of movement. In conclusion, the conducted research shows the possibility to use image signal parameters for distinguishing of terrain on which prosthesis user is moving. Algorithm of terrain identification is proposed. It uses signals from gyroscopes and image sensors. The accuracy of proposed solution cannot be determined before the development of experimental setup and providing study involving amputees. Thank you for your attention.
Thank you very much. Do you have some results with real human, some statistics and estimation of quality?
With amputees, there was no experiment yet. Yes, and now it's planned to construct experimental setup with gyroscopes, and it's now constructed. After that, maybe some experimental experiments will be held.
Okay, thank you. Thank you very much. Any questions from our room, friends? Okay. Also, no questions in YouTube. In this case, next presentation, and after this, we have some breaks for discussion and for switch to keynote speaker presentation. And the last presentation of this block, Valery Slizov, estimation of the optimal radar position for the contactless foul detection.
Yes, I'm here.
Yeah, let's start, please.
Can you see my presentation?
Yes.
Okay. Good morning, ladies and gentlemen. Let me present you the latest results of the study aimed to estimate the optimal height of the radar placement for the contactless fall detection. To the date, the elderly fall episodes pose a serious threat to their health and life, so the development of the effective and precision method for the fall detection remains one of the most relevant problems for the GI. The most commonly used methods, such as wearable devices for the fall detection, video-based methods, and ambient sensor systems, are presented on this slide. The main disadvantage of the wearable devices is their obtrusiveness and necessity for the patient to constantly remember about his device. Commonly used contactless methods, such as video-based and ambient sensor systems, have its own minuses. Its privacy violation and room layout demands for them. Over the past few years, there have been a number of researchers keen to explore the bioradiolocation-based systems for fall detection. Bioradiolocation is a method for remote detection and diagnostics of biological objects by means of radar, even behind optically opaque obstacles. This method is based on a modulation of a radar signal reflected from the body surface, and it does not violate privacy and does not require any special room layout. Moreover, this method does not require any attention from the patient, which is especially important for the elderly people. The problem of the optimal radar positioning still remains one of the uncovered aspects, but may have significant impact on the fall patterns detection precision. So the purpose of this work is to determine the influence of the different radar heights on the fall detection performance and conclude which will be optimal for the more accurate detection of high intense movement artifacts. For the experiments, two biorad-scan radars have been used. Technical characteristics are presented on the slide, and we can return to that later if you want. The experiments were conducted in the standard time apartments using the two radars, which have been mounted on the height of 0.5 and 1.0 meters respectively, as presented on the slide. During the experiments, one healthy volunteer was asked to perform 3 types of high-intensity movements: squatting, jumping, and falling on the mattress at the distance of 1.5 meters close to the radars. Instructions for all type of movements were identical, and list is presented on the slide. As a result, 16 10-second signals were recorded containing one event of high-intense movement at a random moment of time. Signal analysis was performed in the Python environment. All recordings were marked manually to distinguish each type of movement performed. For the signal preprocessing, we used an octangle demodulation technique plus digital filtration using the low pass butterworth filter. Afterwards, each file has been cut to extract 2 1-second segments of signal with no movement, class 0, and with high intense movement artifacts, class 1. For each recording, several features have been calculated: minimum and maximum amplitude, standard duration, power spectral density, and signal energy. Skewness and kurtosis of the distribution have also been computed. All features for each radar and each class were normalized using the min-max scaling. After that, comparative box plots for the feature vectors have been built, and 2 non-parametric tests have been applied to estimate statistical significance of the results, and found out the impact of bi-radar positioning on the analyzed parameters for both bi-radars. The results of the experiments are presented on the slide. Comparative box plots highlight the most effective features for determining motion artifacts for both radars. This is minimum and maximum amplitude and standard derivation in time domain, and power spectral density in frequency domain, which differ the most between class 0 and class 1 signals. Furthermore, difference between values seems to be more significant on data from radar number 1, which has been mounted lower than radar number 2. In accordance with the obtained data, we can make a conclusion about the preferable radar placement height for an automatic fall detection. Our results showed that data from the radar number 1, which has been placed on the height of 0.5 meters, provide more distant information to distinguish high-intense movement artifacts from the bioradial location signal than the radar number 2, which has been placed at a high level of 1.0 meters. The Mann-Whitney U test and Kruskal-Wallis H test results given on the slide also confirm statistical validity of the discovered differences. The study was supported by the grant of Russian Foundation for Basic Research. Thank you very much for your attention. If you have any questions, I'm ready to answer them.
Thank you very much. Great presentation. Any questions from our colleagues? Okay, one question from me. I know that radio signal is not safe for people. Does your device, do you check the safety and safety of your device? And what happened if some radio signals will interfere or reflect from different surface from, for example, from refrigerator and other devices that's present in some rooms?
Yeah, I will answer for the safety question. As you can see on the slide, the radiated power density is less than 3 microwatts, and it fully complies with the Russian safety standards because the limit is 25. So it's more than 8 times lower than our safety standard. And what about the second question? It is the problem for the future studies, and we will estimate how the radar positioning and their positioning in the system of 2 or 4 radars will behave, and we will conclude if it's better or not.
Okay, thank you very much. I want and the second I repeat my second questions. What happened when do you check how this device work in real real room, in not in test case but in real flat or
Yes,
in
yes.
medical? What's happened near to big metal devices like microwave, like refrigerator, like some steel things. Yeah.
We didn't test that for now, and I think it will be interesting to check it in future experiments.
Okay. Thank you. It's good presentation, and currently it's the last presentation is this blog. I sent a link to the next Zoom, to the section 2, because keynote speaker will speak in the second 2, but we have some times for discuss for open discussion of some results as for some presentation. I encourage you to discuss and say your ideas. I'm very impressed with the last presentation because it's have some real studies, real measurements, and also the first presentation is really very good because it's provides some statistics, some information about how this device work. Maybe we discuss it about this a little bit more because I know that many people create some devices, but don't check. Okay, friends, are you here? No one.
Can I answer the last topic that was about device that
Yeah, of course. Let's start.
I want to ask a question to the last lecturer that had the device that can track motion, I guess, or what it is tracking.
It's not really a motion tracker. It's more like the radar reacting for the rapid movements. For example, falling, as we presented in our presentation. So we cannot track small movements with that, but yeah.
What is the purpose of like knowing? What is the purpose of this device? Again, I maybe I just skip that part where you are explaining.
It is used for the fall detection for elderly people, because it is a big problem with the elderly people. If they fall, they cannot help themselves, and we need to inform maybe relatives and doctors about the falling, and if it happens automatically. Falling? Yes, falling.
Oh, okay, I get. So you want to achieve. You want to make that others know when the elder people fall, and then
yes,
they can help them.
Yes, if they're living alone, no one can help them. Did I answer for your question or not?
Well, yes, but I think that the perspective kind of too simple, maybe.
Could you tell me why?
Hmm?
Could you tell me why? Maybe we will discuss it.
Well, no, to develop such a device for only where the only objective is to tell people that someone is someone fell from from the bed or in the corridor. Well, usually there is there's supervision after these people, like special personnel that watches that these people are safe.
Yeah, if you are interested, you could check the second subsection where the similar development is presented. That radar cannot only be used for the fall detection. It has many different approaches with the different radar setups, and the fall detection is only one of them.
Mm-hmm.
And as you said, that it always that those people always have supervision. That development is aimed to maybe help those people who doesn't have the ability to have that supervision, because they're also pretty big queues to take that supervision from the government, and some people just don't have many relatives or live in the different country, and so this is the cases.
Can
Thank you for your questions.
Well, yeah, you answered, but I have another question. Can you tell what are other types of use of this device or the concept of this device?
I can give a link to the study, which aim to control the movement of the rodents, and you can see in this study that it is more like a movement tracker, as you said, because the radar is more, it has more sensitivity.
You mean analysis of mouse motor activity?
Yes, yes.
I see.
Also, it's used to control breathe during the sleep, to control sleep in apnea, which has been the case of the first presentation, if I'm not mistaken. And you can also read about it. I could link you if you're interested.
The speaker of first presentation is here.
Yes.
Yeah, maybe you say something about your presentation, because some people interested in your results.
So I can say a little. Maybe some questions you can.
Maybe you turn your camera for more fluent discussion, for look some emotions. Yes. And also other friends, maybe we really turn on camera for. Yeah. Thank you very much.
So I can talk a little bit about some questions. What can you ask me? So at first we didn't tell about our considering with other methods. So I can say that we decided that it's appropriate to compare our method, new method, with basic ones. So we talk about polysomnography and respiratory polography. I heard about bioradiolocation, and I heard that it can be used for diagnostic of noise syndrome, but we didn't know a lot of about this method, so it is interesting to hear how we can diagnostic this pathology with using bioradiolocation. So maybe last speaker can explain this. Last speaker.
Oh, I'm sorry, I don't have my microphone.
Yes.
I guess it's better to maybe ask people who use that method for the sleeping apnea control, because I really afraid to say something not right in that sphere.
Okay. Okay, so I can tell that we, at the moment, if we talk about our results, didn't solve the problem of removing artifacts or noise from the signal. So at the moment, these problems can solve, and we will do this in the future. And I can tell a little about our the automatic algorithm. We talked a lot about it in our presentation, but we didn't explain it. So in short, the essence of the algorithm is as follows. It searches for peaks by looking for the values that are subordinate by lower or higher values for the height and low respectively. So it's it's a little about our algorithm. Maybe questions.
Some people stuck in discussion. Okay, could I ask questions last presenter about radio location? I'm interested. Could you use your technology for epileptic seizure prediction? Oh, sorry, not prediction, but detection, because some people's install cameras and detect fall and start of seizure in by cameras, but it's little bit uncomfortable for people to live with a camera 24 hours per day. It's difficult for other people in home, and I'm interested. Could you solve and predict, not predict, but detect this event without video signal and without?
Yes, thank you. It's very interesting approach. I guess it's possible, but it needs some more looking into that. I think it will be partly the fall detection, and after that, maybe with a different radar, with a different setup, we could somehow detect that seizure.
Okay, I don't know. Unfortunately, I can't help you with this. I only once take a participation in a conference of neurophysiologists, and I see this problem and something other, but I have no contacts from these people. But if you work in Moscow, I suppose it's not so difficult to find some collaborators from in Moscow, because a lot of people work with Sage and this stuff. Yeah, maybe it's help you with some ideas.
Yeah,
I'm
interesting to discuss.
okay. I asked also about two other presentation. Is it's after here? Maybe some other people in this room. I'm unsatisfied by quality of some presentation. It's not quality, but I'm await some results, some statistics, some measurements of people, and yeah, I interested what people think, why they present only some work like technical work, but not results, and I try to understand why people don't do this. What's problem? Or maybe it's a big problem to find volunteer for test system, or what's happened. Why?
Well, the problem with volunteers is surely apparent. But you are questioning someone specific or in general?
In general, I'm like chair of this section. I am interested to raise quality of conference, quality of presentation, and make it much better. For this reason, I'm asked general question. What do you, what's really what's the trouble to improve quality of work with some studies with volunteer or something? If we not if this many of devices is only diagnostic device, it's not a treatment device, and for this point of view, test for 1 or 3 volunteers, it's not a big problem, and in sometimes it's not require ethical commissions if this really safe device. Yeah, I am interested in what's happened with also, many people make system and test only sensitivity. It's also good ideas to test sensitivity, quality, compare results with other device, test device on physical phantom, like model of human body, test on some small devices, for example, blood flows and some tissues. Ultrasound device has special test test models, physical models with skin and small small tubes inside with water or some liquids. Electroimpedance studies test on phantoms. Ultrasound, electroimpedance. Yeah, maybe it's not so difficult to create phantom. I want to understand why people don't do this. Yeah, didn't do such studies.
You mean artificial models? They don't use artificial models? Or...
Yes, artificial models become two types. It's computational models. It's one approach. I know that's a lot of. I see a lot of computational models in previous years. I suppose I see also some works after in the next blocks, but many people who create physical device testing on some physical models.
Well, I personally can't answer this question because I use more conventional devices. But I think maybe, well, I myself experience some shortages on volunteers, especially at that time of the year. But well, there wasn't a problem with volunteers like in 2018, 19, and before that. The problem is that, well, I struggle with some documentation which needs to be written for ethics committee, and there's a lot of restrictions, and volunteers sometimes, well, the quality of study depends on the volunteers themselves. Sometimes it's just not the right type of volunteer that then I can perform.
Okay, but if you have problem with ethical commission, maybe you need to collaborate with some medical organization and with people who can pass. I know that many young researchers from clinical and from medical school can't pass ethical commission because they have no not authority, but have no permission for treat people before finishing. Yes, before finishing some stages, but maybe collaboration with more experienced colleagues can help you.
Well, there is a collaboration already. It just, well, you know, maybe it is for this year. There is a lot of restrictions, but well, to have a skilled medical expert, it is like it needs a little bit more funding, because the medical expert also will not be doing this type of work for free.
Yes, but medical experts also rise his career via PhDs. Great, and many researchers from medical organization interested in some articles and some studies for write his PhD and for gain higher position in his organization. And from this point of view, it's more easy to find clinician than, for example, machine learning specialist, because machine learning specialists can't rise in his position with some articles in Russia. In Russia, it's not so important for them, but for clinician, it's only one way to gain upper position.
Well, I get what you're saying, but I have a medical background, and I can say that a lot of clinicians are not really interested in scientific work. So it is a matter of a person themselves, I think.
Yes, I understand that it looks like clinicians not interesting, but it's not true, because a very small percent we stay our opinion about interest of people based on speech of our experienced and aged colleagues that describe how cool to do science in Soviet Union and how research performed later. But really, in any fields, in machine learning, in medical schools, in biomedical engineering and other places, only small number of people interested in science and make careers through science. But it's not the zero people. In any university, we can find some people who really interested in things that you do, and also you have no one. Not in one city. You can find some researchers from St. Petersburg, Moscow, and other cities.
No, I'm not telling that there's nobody who is interested in science. There is certain some people that are interested. It is just hard to find some of them.
Yeah, it's a general my point of view. Yes, you clearly explain what I say. Okay, we have only 9 minutes to start of keynote speaker speech. It's Konstantin Danilenko, behavioral and physiological consequences of acoustic neurostimulation during slow wave sleep. And keynote speaker will speak in the next section. I sent link to Zoom in this chat, and I sent now I sent link to translation in our chat in YouTube, and I hope you connect to this speech, and after you reconnect to these blogs and ask questions to other researcher, increase your increase widespread. You obtain new ideas, new things, and look at work of your colleagues from other universities, from other cities, and also find new contacts for collaboration. Thank you very much. We take some breaks, and after the speech of keynote speakers, we return here at 1:15 p.m. Thank you very much. I start break, how it named, break thumbnails. Have a good day. I hope to see you later
Thank you.
today.
Thank you. Thank you.
Здравствуйте, Константин. Константин, можете мне ответить? Константин, вы меня слышите?
Oh, sorry. Dear friends, hello.
Вот это время, которое показывает, я не понимаю, что это за время, час 15, по-московски 11:15, час 15 по какому времени вообще?
For local time in Yekaterinburg. In the beginning of the page for where the schedule is presented, write it time in Moscow and time in page recalculated according to time in your browser.
Ничего я не поняла. Московское время. Скажите по-русски, никому это не надо, что вы по-английски сейчас говорите. Вот у меня сейчас 11:15 по Москве, час 15 это по Свердловскому времени?
Excuse me, official language of this conference is English. It's requirements.
Я понимаю, да. Ну, в общем, издевательство. Спасибо.
Okay, ask again about Alexei Anistimov.
I'm presenting on his behalf.
Okay, you will present this conference. You will present electrophysiological technique for exploring and this presentation. Yes.
Right.
Okay, thank you. Thank you. I suppose we can start. Let's start, please.
Okay. I'm a main author of this article outline, electrophysiological technique, exploring cerebral hemodynamics and brain biological activity during postural changes. This topic is a more specific topic than the previous one. The previous one are a more general outlook on the current study. First, I want to address some to introduce you to several concepts of postural, how posture affects the human body. Firstly, the posture affects distribution of blood and other body fluids in greater detail than previously thought. And adaptation to postural changes can develop due to cerebrovascular regulation. There are several articles that describing these changes in regulation. Also, these articles use electrophysiological methods that shows signs of this regulation by being observed. Let me correct myself. This regulation is absorbed by registering specific changes in brain biological activity. And this research work examined electrophysiological and blood flow parameters in the brain during dynamic, not static postural changes by combining methods of EEG and REG. And then these results was quantitatively assessed, and then there's some correlation between functions of central nervous system and cardiovascular system was found. what materials and methods were used. Here on the picture presented as the study design, the test subjects was undergone several postural changes on tilting table, and what was measured, it was the power of brain waves, brain blood flow, and blood pressure was considered measuring, and after that the data analysis was performed. What postures was used in the study? On this graph here we can see that the first posture was vertical, sitting vertical, 90 degree. Then after that, there's stage 2, which is supine, horizontal, and in stage 3, the participant lowered to head down tilt, minus 45 degree, and then again he returned, or he or she returned to supine posture. Mean duration of certain body posture equaled 5 minutes. These lines between segments depicts mean time frame for acquiring a new position, which equaled around 1 minute, 1 or 2 minutes. Here, modified scheme of conjoint REG and EEG electrodes. Here we can see that these white circles represented EEG electrodes. They were placed in conventional 10-20 system, and the red electrodes were REG electrodes. And we can see the results here. The right picture represents REG data. REG data from REG was data from cranium was divided into 4 leads. These 2 leads from frontal leads, and this lower 2 from occipital leads. And as we can see, the difference between supine and head down positions is that the amplitude of rheogram was much higher than in the supine, and this means that that more blood was flown into the head during minus 45 degree position, and after returning it is decreased, but still had a higher amplitude than in the supine. Here on the right side, there is EEG data. S means sitting position or vertical. H1 is horizontal before head down tilt. A anti-orthostatic or head down tilt, and H2 is horizontal after head down tilt. And in the vertical or sitting position, here is apparent that we have alpha activity here, which is depressed in the already depressed in the horizontal position, but sometimes in some participants after head-down tilt, they have a little bit of alpha waves in the occipital region. And after returning to horizontal position, there's again no signs of alpha waves. And further results show that changes in REG, firstly, there was 1.5 or 2 times higher REG amplitude in the anti-orthostatic position. Anacrotic phase, which is the beginning of REG wave, lengthened for about 50% during head-down tilt in relation to vertical sitting position. And at the same time, the declining part of the REG wave, the catacrotic phase, shortened for approximately 25%. Changes in EEG, except obvious depression of alpha waves in supine position, and in some cases in anti-orthostatic position. The group, I forgot to mention that the group of participants was divided into 3 groups depending on the initial power of alpha waves. There was one group with high alpha waves, about 30 microvolt or higher, and the middle group of volunteers with middle power alpha waves, which is written here below. No, it's low power alpha waves, below or equal 8 microvolts square, and the middle group with middle power alpha waves has below 30, but higher than 8 microvolts square. And the group with a low power of alpha waves showed the most significant changes. And spectral power of alpha waves was decreasing in vertical to horizontal position. And then we have a return to initial numbers in head-down position. After returning to supine position, alpha spectral power lowered again to the numbers of previous supine posture. What is a correlation between REG and EEG? It was that most volunteers appeared to have REG amplitude to be inverse correlated to alpha wave spectral power. Others showed a direct correlation, which means that for some participants, more an intense brain blood flow can decrease alpha waves, and for some it's other way around. REG amplitude connection with delta wave power also was splitted, but in 50-50 ratio. REG amplitude had a direct correlation with theta wave power, but this correlation isn't very significant, I should mention. Here you can see a scatter plot of inverse correlation between REG amplitude and spectral power of alpha waves. Here it's pretty strong correlation, if we can see on the parameters of statistical significance. What we can say, how we can interpret these changes. First, the rise in REG amplitude could probably be contributed to the increase of brain blood flow, as I said earlier, but also we can't dismiss the influx of cerebral spinal fluid that can also affect the transmission of the signal from the brain activity. Higher intracranial pressure and or brain blood flow can affect neural electrical transmission, which can make possibly can make amplitude and power of alpha waves to drop. Also, we consider that there is a work of baroreceptor influence on cortex inhibition. There's a number of studies that showed this connection. And this can make a reduction of low frequency biological activity. There also a role of locus coeruleus, a noradrenergic nucleus that had a widespread connection throughout the midbrain and also to the cortical cells, and have a major role in alpha wave depression. And in making some conclusions, the results showed possibilities of the described technique to register hemodynamic and electrophysiological parameters of REG and EEG in a simultaneous way and explore complex neurovascular interrelations under certain postural conditions. And direct and inverse correlations were discovered between REG amplitude and spectral power of brain waves for sure, but underlying mechanism of this phenomena is still to be explained. So several hypotheses from straight effect of blood and cerebral spinal fluid pressure on brain functions to a principal role of locus coeruleus in cortex inhibition are here to be considered. And that's all. Thanks for attention.
Thank you. We are waiting questions about this great presentation and great results. Okay, one question for me. When you placed electrodes above eyes and near to head, near to this muscle, you obtain very strong noise from muscle when people rotate head and make some movements. Also, you register the section of in eyes. How you filter this signal and what you do with this strong noise?
Well, we strongly suggest that volunteers should not move their head and eyes. Oh, I forgot to mention that the recordings were performed when volunteers work with closed eyes, and you mean when there's electrodes FP1 and FP2, they were changed with REG electrodes. Can you see the display, what I displayed here?
Yes.
Here, this red electrode is a rheographic electrode. So the actual EEG electrodes are further away from eye muscles. So there's really not that much effect from these muscles to the signal, but also in the program WinEEG was certain filters installed to dismiss those types of artifacts.
Okay, thank you. Thank you very much. And the next presentation, this is a presentation of recognition of sleep apnea by EEG using nonlinear dynamics methods. Ludmila Manila, are you here?
Good afternoon. My name is Karina Starchenkova, and I am the second author of this report.
Okay, thank you. Let's start, please.
One moment. Theme of the report: recognition of sleep apnea by EEG using nonlinear dynamics methods. Slides goes over or not?
No, with some dilation. Maybe you start a presentation with a 5 button and okay, let's try to switch.
Thank you. Obstructive sleep apnea is a disorder characterized by frequent interruptions in breathing during sleep, usually accompanied by snoring. Currently, obstructive sleep apnea syndrome is diagnosed using a polysomnography, a method of recording body activity during sleep, and pulse oximetry, which measures the amount of oxygen in the blood at any time. Obstructive sleep apnea itself is not a life-threatening condition, but it can cause serious problems such as cardiovascular and cerebrovascular disease. The aim of this work is to develop and study entropy methods and the highest Lyapunov exponent for solving the problems of recognizing sleep apnea using an electroencephalogram. Signals taken from the CAPSLEEP database in PhysioNet, sleep apnea has been associated with disorders such as narcolepsy, bruxism, periodically movement syndrome, sleep apnea, and nocturnal frontal lobe epilepsy. It should be noted that these disorders are found in different sections of the ICSD-3 classification. The paper investigates entropy methods and the calculation of the highest Lyapunov exponent in relation to the problem of recognizing sleep apnea by EEG. Lyapunov exponent are estimated by the trajectory breathing speed. Using this indicator, we can determine the presence of the chaotic component in the biosignal. The presence of positive value tells us that the signals belong to the nonlinear class. From the analysis of the literature, it follows that the single Lyapunov exponent makes it possible to identify a dynamic system in terms of the presence of chaotic behavior in it, and is also capable of reflecting the level of signals chaos. Calculation of the time delay and dimension of embedding space is necessary for the correct calculation of the Lyapunov exponent. In this work, time delay is determined by autocorrelation function method, and the dimension of the embedding space is determined using two methods. It's the method of false near neighbors and the correlation dimension. The calculation of the highest Lyapunov exponent will be carried out by the method proposed by Wolf. The formula for calculating the highest Lyapunov exponent is presented on the slide. The dimension of the embedding of the attractor for the relation considered in the work was different. Therefore, the dimension of embedding space equal 8 was chosen as the dimension of the embedding of the signals because it corresponds to the dimension of the embedding of the syndrome of periodic limb movements. The results are shown in table 1. It's difficult to recognize sleep apnea from these results. The senior LEPNF exponent is approximately the same for all sleep disorders. The senior LEPNF index in nocturnal frontal lobe epilepsy is most pronounced. Entropy is a quantitative measure of chaos in a dynamical system. There are several types of entropy and accordingly methods for calculating it. The analysis of biosignals using entropy is finding ever more widespread use. Approximate entropy, according to the results of recent studies, the approximate entropy has the greatest predictive value. The approximated entropy is a characteristic of the internal order of the time sequences of EEG signals. Mathematically, it reflects the probability of detected two neighboring vectors in sequences that defy the passing from the space on bidding dimension m to a space of dimension m+1. Shannon's entropy. This approach connects entropy with the amount of information in an information message and define it as a measure of the uncertainty of the state of a physical system. The entropy in Shannon's formula is the average characteristics, the mathematical expression of the distribution of the random variable. In Mathematica, Alfred Ragnier offers this generalization of entropy. He introduced the entropy as Q, the moment of the measure of epsilon partition. The constant Q can take many values, but the meaning of the Ragnier entropy, its case, accordingly change. The resulting entropy values for 5 sleep disorders are shown in table 2. It can be seen from the results in table that is difficult to recognize sleep apnea from the approximated entropy. At the same time, using this type of entropy, it's possible to recognize bruxism, takes the lowest value, and epilepsy of the frontal lobe, takes the highest value. Shannon's entropy shows the difference between all groups of signals. And again, the values of bruxism and epilepsy are most different from the rest of the disorders. With Ragnier entropy, we can also recognize sleep apnea from other signals in this method entropy of the greatest importance. To confirm the possibility of using the senior LEPNF exponent for the problems considered in the work, dispersion criterion was calculate criterion F. The dispersion criterion F is based on dividing the total variability of data into intergroup variability, which describes the degree of difference between experimental groups and intergroup variability, which describes the magnitude of random difference between individual samples within each group. The calculate values of criterion F are shown in table 3. The calculate values of F satisfying inequality F less or equal F criterion. Therefore, it can be concluded that these methods can be used to recognize the stage of sleep. The smallest value of the criterion was shown by the approximate entropy. That means that it is the least effective method for recognizing the sleep apnea. In this work, we carried out a comparative analysis of the entropy characteristics and the highest LEPNF exponent in the problem of recognizing sleep apnea by EEG. For all methods, the analysis of the dispersion criterion F was carried out. It was found that all methods expect except for the approximate entropy, have a sufficiently high efficiency and can be used for recognizing sleep apnea by EEG. As a result of the work, accuracy of the presented methods was calculated. The obtained results of the study are a good indicator of the possibility of using the proposed nonlinear methods for further testing the data obtained in real time. Thank you for your attention.
Thank you. Very interesting presentation. Sleep apnea is a really very big problem, and a lot of studies in biosignal processing focused on its detection. I'm waiting questions from our colleagues, because here a lot of specialists who work with EEG. Okay, questions from me. You present some statistics with mean and standard deviation in your presentation. Have you compared the results of these indices between patients or between intervals in one patient? Dispersion, is dispersion described by inter-subject variability or variability in time?
Thank you for your question. In this work, we applied the signals from the certificate database, and we use signals from the different patients and of the different age. We see that these methods give good results, and the next step, we will apply these methods in the real time.
Okay, but do you compare? Do you know from your point? I try to understand about robustness of this method, because you provide some results, and from your point, from your tables, I see that entropy is very stable criteria, very stable indices with very small standard deviation, and you show that for bruxism and for apnoea, we see some values of this entropy, but I don't understand how it works in time or from various patients. Maybe you want to do this in the future, or you have some opinion about this.
In a real station, we apply it in the future. Now we takes signals, we cut it into the episode with this contain the disorders, and apply this method from these segments.
Okay, thank you. Thank you. The next presentation is Alexander Dmitriev, the influence of vibrotactile finger stimulation parameter on P300 characteristic changes for rehabilitation, pilot study on healthy subjects.
Okay, my name is Ivan Kremitsky, and today I'm going to present this research.
Thank you. Let's start with your presentation.
Okay, do you see the screen?
Yes.
So, hello everyone, my name is Ivan Kremitsky. I am Bauman Moscow State Technical University student, and today I'm going to tell you about our research, the influence of vibrotactile finger stimulation parameters on P300 characteristics changes for rehabilitation, and we have made pilot study on healthy subjects. According to statistics from the Ministry of Health, there is an increasing trend in the incidence of stroke and a decreasing mortality rate. Patients after stroke have motor disorders and visual disorders. Today, there are different methods of post-stroke rehabilitation, such as physical therapy, pharmacotherapy, basic therapeutic exercises, and high-tech methods, including brain-computer interfaces. Different types of brain-computer interfaces are used for rehabilitation and improving the quality of life tasks. There are several modalities: visual, auditory, vibrotactile. Brain-computer interfaces based on vibrotactile stimulation have some advantages, as we make rehabilitation for patients with photosensitive epilepsy and patients with visual impairments. Stimulation is also performed on the area that should restore movement. As a result of vibrotactile stimulation, a nerve impulse is formed and the response occurs in the cerebral cortex. In our study, we work with the vibrotactile brain-computer interfaces for upper limb rehabilitation tasks in post-stroke patients for whom it is not possible to use a brain-computer interface with visual or audio modalities. By taking a signal from the surface of the scalp, filtering and coherently averaging it, we extract the component of the evoked potential, the target P300. The P300 is a positive component appearing at the 300 milliseconds region in response to the occurrence of a target stimulus. On the screen, you can see the typical evoked potential graphics and its P300, also called P3 component. Due to previous researches, no one worked with vibromotors, and the results in common quality are not specified. That's why the tasks of our research presented on the slide. The EEG signal was recorded using a neuron spectrum 5 electroencephalograph. Electrodes were placed according to the International System of 10-20%, and the most significant were CZ, PZ, and A1 and A2 electrodes were used as a reference leads. The ground electrode was placed in AFZ. We have used QX6A3V vibration motors, which were controlled by MSP. The experiment consisted of 9 series. Each series used a different stimulation frequency and the duration of vibrotactile motor exposure. The stimulus were presented in a pseudo-random order, but unknown to the subjects. To equalize the number of averaging epochs of target stimulus and non-target stimulus, each of the non-target stimulus was assigned to one of 8 randomly selected groups. On the left side of the slide, you can see the amplitude in bars and latency subscribed in the center of bar in each series of the research due to CZ and PZ electrodes. The resulting plots had variability in P300 amplitude and latency. On the right side, you can see the typical graphics of P300 for the subjects. P3 amplitude was considered as the average EEG signal maximum value at 220 till 450 milliseconds interval. The following table shows the ratio of P300 amplitude to noise. The difference between the counted stimulus by the participant and the number of stimulus per series called error. If the ratio is strictly greater than 1.1, we will say that the P300 was extracted. Otherwise, the P300 couldn't be extracted from the signal. Noise in our calculations, we will consider the signal of non-target stimulus. To consider the series in dynamics, it was decided to divide each series into 5 equal windows, into 5 equal sections, and look at the extraction of P300. The extraction in sections is lower than in complex, and the smallest result was 0.1 and the biggest one was 4.0. To explore the order of target stimulus, averages were carried out for consecutive stimulus, for which the target-to-target interval was minimal and equal to 1 stimulus, as well as for rare stimulus that were not consecutive. The averages for each selection are plotted in the same graph, with red for consecutive stimulus, black for rare stimulus, and blue for the remaining stimulus. The smallest P300 amplitude and the smallest signal-to-noise ratio occurs at vibrotractile stimulation with a frequency of 4 Hz. The largest P300 amplitude is obtained with low-frequency stimulation at 1 Hz, and the shape of the signal is similar to the results described before us in previous researches, as you can see on the slide. Since with an increase in stimulation frequency, there is a change in which significantly affects the amplitude time parameters of the P300. It is not entirely clear what has a greater effect, frequency or target-to-target interval. Therefore, the data show the dependence of P300 amplitude to a greater extent on target-to-target interval than on frequency. Due to the small number of subjects, these dependencies are only approximation. The duration of exposure to the vibration motor has no effect on the characteristics of the P300. In each of the series of stimulation, a division into 5 equal intervals was made. If the P300 was successfully extracted in a small time window, it is possible to reduce the detection time. With this approach, the detection accuracy decreased. During registration, participant 2 made mistakes when he counted stimulus. But there were no significant changes in P300 due to this. And to confirm our pilot study, we need to expand the experimental sample with many subjects. In conclusion, I'd like to say that we have reached higher amplitude of P300 with frequency of stimulation about 1 and 2 Hz. Based on the small experimental data, we can conclude that P300 extraction and amplitude do not depend on the stimulus duration. Contribution of target stimulus with minimal target-to-target interval is negligibly small, and in future research, we should create a sequence with large target-to-target interval. Thanks for your attention, and now I'll be glad to answer on your questions.
Thank you very much. It's really good results. Are we waiting questions from this room or from YouTube? Dear friends, we listen about 3 presentation with EEG processing. Maybe some people want to ask something about device or technique of processing. Okay. Okay, you say that your process used your approach on healthy subjects. How
Yes.
you, yes, where you make your studies and how you pass ethical commission and other issues?
Please, can you repeat the question?
Where you make your experiments with test subjects, with patients, and what ethical commissions passed this study? Do you work in some clinics or how is your research organized?
I worked in the clinics which is in my university, and here we took 2 healthy subjects to take these results.
Oh, it's good. It's very good that you have access to clinics in university. It's really great advantage for your study. Thank you very much. And the next presentation is sorry. It's the latest. The next presentation is last in this block. in our section, but I hope you stay in break and raise some discussion. For example, I propose some topics for discussion. It's methodology and how important to make methodology clean, and how important to process our signals according to basic recommendations. Okay, the last presentation, Alexander Dmitriev, temporal and spatial parameters dynamics of CCVEP during long-term low frequency lead stimulation pilot study. Okay.
Today I represent this article.
Okay, thank you. Let's start.
Do you see my presentation?
Yes.
Okay, let's start. Good day. My name is Irina Minenko. The theme of my today's report is temporal and spatial parameters dynamics of SSVP during long-term low-frequency lead stimulation. Brain-computer interface, BCI, is a communication system that enables paralyzed people to directly communicate with and control of external devices without body movement via analyzing the user's brain activities, in particular EEG. Typical paradigm in the EEG signal, namely P300 in relative potential and steady-state visual evoked potential, SSVP, are used to analyze brain activities. It was found that the change in the shape of evoked potential of P300 and its amplitude decreased during fatigue and habituation. The operation speed and BCI reliability decrease due to these factors. And there are other similar changes in SSVP due to the fact that it's necessary to use visual stimulation for both P300 and SSVP-based BCIs. EEG responses to periodic stimulation are termed steady-state visual evoked potentials. The response spectrum has narrowband peaks at frequencies that are directly related to the stimulus frequency and its harmonics. SSVP-based BCI has received extensive reach interests in the past decades due to its fast information transfer rate. The BCI usually utilized several visual oscillating stimuli, such as leads or figures on a computer screen. According to most studies, the occipital area of the cortex generates SSVPs. Its characteristics in terms of amplitude, frequency, and phase are commonly assumed to be stationary. But one previous work showed that the amplitude of the first and second harmonic frequency components of SSVP were in general not stable over time for flicker stimulation at 15 Hertz frequency. And the slide illustrates the aim of our work and experimental research. For us, it was important to answer the question, will there be a problem of stability of BCI systems based on SSVP in long-term use for different frequencies? In our case, for 9, 11, 13, and 15 Hertz. And it's important for us to find out the distribution of SSVP sources on the head, and based on this information, optimize the position of the electrodes for such systems. EEG registration was performed using a narrow spectrum 5. A lead matrix acted as a photic stimulator with an angular size of 44 degrees and with wavelength 564 nanometers, which corresponds to the green color. And the electrodes were mounted according to the international system 10 to 20. Slides illustrate parameters of experiment series and experiment scheme for each subject. The study involved a healthy man with a normal vision in the age range 20-22 years. The experiment alternated between stimulation and pause when the matrix was turned off. Signal spectra were obtained using the discrete Fourier transform for all stimulation period for 100 seconds for each frequency, as shown in figure 1. To assess the SSVP dynamics, the signal was divided into intervals of 5-second duration, and the short time Fourier transform was performed for each interval separately in step of 10 time samples. Graph in the frequency time domain shown in figure 2. And it was noticed that in different stimulation settings, the errors with a pronounced spectral amplitude of SSVP are synchronized with the increase of algorithm. Building on the results obtained from short-time Fourier transform, K ratios for each point of time were calculated according to the formula on the left side on the slide. The value ratio K illustrates the relationship between SSVP and the algorithm. Further, the errors under the graphs in 10 seconds intervals and the relative changes in errors were calculated according to the formula on the right side on the screen. The relative error variation values can be used for evaluating the SSVP, similar to a process with tendency to increase, decrease, or random amplitude change. And criterion for estimation is on the slide. And all values in the range from -2 to 2. To assess the SSVP spatial dynamics signal was divided into 10 sections with a duration of 10 seconds. Topographies of the main stimulation frequency spectrum values were constructed. A common spatial pattern filter was applied to separate the SSVP sources from the spontaneous EEG. And figures shows the topography before and after applying common spatial pattern for two cases. SSVP is extracted from signal successfully for subject A and not successfully for subject B and C. And there are some discussion points. The habituation effect could explain decrease in SSVP amplitude in some cases. And on the contemporary, different characteristics at time of various adaptation process and involuntary eye movements could explain the increase in SSVP. But in general, no rhythm changes have been detected in our voluntary signals. And for further research, maybe the SSVP and eye tracking synchronous registration, application of the Lyapunov index, and correlation analysis, and averaging to clarify these aspects. The SSVP distribution obtained maps show that the largest amplitudes of the stimulation main frequency are located in the occipital, parietal lobes, where the visual work potential and sensorimotor is generated, and central lobes. Common spatial pattern filtering for SSVP detection was successful only for one subject, maybe due to filter lack efficiency or SSVP intra-individual variability. And it's advisable to use the independent component analysis and increase the spatial resolution in the occipital parietal lobes. And brief conclusions are on the slide. Based on a small experimental sample, a conclusion was made about a random process of dynamics of SSVP changes for frequency 9, 11, 13, and 15 Hertz. The SSVP source's spatial location is more stable, although there are local changes in the occipital-parietal region. And thank you for your attention. I'm glad to answer your questions, please.
Thank you very much. Questions, please.
Yes, I got one question. Are there, Irina, are there other algorithms for filtering the EEG signal besides CSP, and why do you use CSP?
Of course, there are, thank you for the question. Of course, there are a lot of algorithms to separate some oscillating activities in brain signal from spontaneous EEG. And common spatial pattern, one of the algorithm which based on a theory of a linear combination of sources in the brain, and independent component analysis based on such theory, and of course exists another algorithm, and of course exists unlinear algorithm, but I'm not ready to name it. Okay, it is clear. I answer.
Yes, it's clear. Thanks.
Okay, thank you for answering. Thank you for question. Okay, currently we have some break until the next block. We are waiting that all people stay and listen the following presentation. But currently I want to write some discussion and talk about some research topics for exchange experience and something other. For example, I write topics of I propose topics for discussion like what's importance of the clear methodology, because I see that many people make some processing and big steps in this processing is omitted and performed with some other kind of stuffs. And in some cases, it's significantly influenced on the obtained results. I can propose example from electrocardiography processing. There is RMSSD, it's indices of heart rate variability, and if you take any work before 200 before start of this century, you found that this index calculate from any error intervals. But current studies calculated with exclusion of any ectopic activation, without any atrial arrhythmias and other stuff. And for this reason, values of these indices may be significantly changed in different devices and in different processing methods. Maybe we start to discuss this. Maybe we can propose some similar example in your field of studies, and how you work in your groups with methodology and clear following the proper and clear processing of the data.
So how we work with the clearing?
How we work with processing and repeatability and repeatability of results, and how we work with clear. Okay, if small changes in methods of processing can lead to significant changes in statistical comparison of subjects. I propose some example from electrocardiography, because some devices use old methods, old definition of one indices, and modern use other definitions. For these reasons, you obtain significantly different results. Maybe you can I encourage you to turn your cameras and discuss in live discussion, like on coffee break or something similar. Maybe, yeah, maybe it's more interesting for some people.
You meant how to connect heart rate variability with some other data?
I mean, that's the basic index. The basic evaluation of heart rate variability, RMSSD, in different studies used from different definitions. And for healthy subjects, it's not important. But for subjects with atrial fibrillation, it may be very, very different results. We can obtain very different results. And also, I see that some presentation here omit stages of processing and don't say how it filter data, how it work with some issues. What do you think about this?
Well, I didn't work with heart rate variability directly, but well, I heard some proposition that to measure, well, no. You mean that in more old studies, heart rate variability was measured in one way, and in more newer studies, it measured in another way.
It's just example. It's not my. It's not my.
You mean in general?
In general, yes. And I see that you process EEG and you use some processing and some filtering from EEG filtered from ECG, from heart signal. EEG filtered from muscle hypertension, and from other kind of artifacts. And I see that some people used industry devices and used some processing, but others use some processing and write it by himself. And I try to understand how we can compare result and why we should believe to some results if we don't understand clearly what happened.
Well, I use more conventional methods of filtering, like how low pass or high pass filters in EEG. Well, I decide what filter is the most used in other articles, and what are recommendations from the software developer or hardware developer. What are they telling to, what filters are they telling me to set that I have more proper data?
Okay. And why you think that you make all things correct? You only believe this.
Why I think that I receive the right type of data, you mean?
Why you believe in processing that's implemented in your devices?
That's a good question. Well, of course, I have some kind of doubt that this data is that they are real data that can that this data is represents the real issue. But when I receive these results, I usually have some literature background. I read articles that have something similar to what I receive from my experience, from our experience. Of course, I can't can give a definitive answer that my results are the most precise.
Okay, Irina, what do you think about this? And other speakers, I also interested in your opinion.
I hear you. I'm thinking. It's a good question.
I think that if we work with trusted and certified devices, we can believe them. For example, we can believe them for about 5 or 10 years if the electronic scheme are good enough. By the way, lots of EEG, lots of electroencephalographs use just low pass and high pass filters. And the main problem, for example, if we work with the P300, the main problem is to reduce 15 hertz noise.
15 hertz because it's muscle noise.
No, it's not muscle noise. It's noise from the wires from the network. And if we speak about muscles and other things, if we speak about the P300, we use coherent averaging. That's why we reduce the noises from EMG or from the eyes. On EEG, you will always see the artifacts from EMG. And as by the way, these artifacts will be big on the spectral characteristics of the signal. By the way, when you try to average it, it reduces.
Okay, Irina, I see that you use frequency domain for analysis of your data. What do you think about methods like high and low pass filters and about coherent averaging and others?
I filtered my data with in range 5 to 50 hertz with filter with
Okay, and Arlan, this is this band pass which you directly use, or the same band you filter or not?
Wait, I can say precisely. Well, I use a 50 hertz filter for like filtering the how can I say machine noise. If
from this electrical network noise.
Yes.
50 hertz.
Then I used low frequency filter and rejector filter between 45 and 55 hertz. High frequency filter was set on 1, or well, it's 0.16 hertz. it is recommended positions for filter pretty standard, and I was talking with some experts on EEG. They told me that this is the most optimal for my type of research. And that's why I decided to make these filters as it is.
Okay. Other opinion about these topics, maybe.
Could you repeat?
Any other opinion? Maybe. Okay. It's very difficult to to write some discussion because people speak only with me, not paired wisely. Okay, what do you think about ethical committee and tests on humans? Some researchers here has access to clinics, but other work in condition when they need to communicate and collaborate with external organization, and sometimes it's very difficult. What do you think about this? And it's basic inequality in our work. Maybe it's not good, but maybe it's good because ethical committee is good. It's necessary really in sometimes.
Well, ethical committee definitely has its purpose, but sometimes they overdo with their paperwork and ask for a lot of how can I say? They ask for a lot of conditions that should be met, but they are really some unnecessary ones.
And what do you think about animal studies? Because animal studies is easy to pass, and you don't need to be clinical specialist and with high experience for animal studies.
Well, I don't have that much experience with animal studies. I don't know. I don't really know how they are, or what difficulties they have.
Okay, I think that people who work in Moscow has access to strong and very big vivarium with a lot of animals of different kind of animals, and also in Moscow I know about several how it named in English. In Russian it's Центр коллективного пользователя, collective center of research equipment usage. And some people used this facility to reach new results. Also, I know that several centers exist in Yekaterinburg, and maybe in some other cities. Do you have any experience with animal studies and with something similar? Do you try to communicate with a special organization which focused on brain research, for example, Brain Institute in St. Petersburg, or some?
I personally not.
Okay, and how do you see the clear way to extend your research and extend your research facility from your point of in location when you in place when you located? Because for Moscow it's much easy to assess high quality stuffs, and too much clinics are ready to obtain your device for testing. Unfortunately, in the Siberia and Ural, it's not so easy. but also here we can find some unique facility. For example, in Syktyvkar city, people work with in Russia works with big animals, with pigs, with cows and other big animals, and it's a little bit expensive in any place in Russia except this city. And researchers obtain very good results in animal physiology, about especially in heart physiology. And do you know about some possibilities in Russia or in Moscow when you can work, and how you see the further studies? What do you think, other friends? I see that other presenters and also presenter in the next section also connect to us, and currently we discuss in break, we discuss some ideas, some things about research facilities, about methodology, and yeah.
We observed some problems which we maybe successful solved, but I think we need to test it in more more numbers of subjects, and it's far from it's far from a real marketing, real making algorithms in clinics.
But when you say marketing, what do you mean? Do you mean production real device for market?
Yes, of course.
Yeah, but if you want to make the studies for market and for some device, you can raise some funds in special like фонд of фонд содействия инновациям in Russian, and other foundation RFRIT in Russian. It's an abbreviation which mean a fund with very big grants for production of real device and real things.
We planned to make a list to a fundamental research foundation of Russia, but in this year this possibility was reduced.
Because two foundation was joined together for this reason or for other. Why you think it's reduced? Because you need a high quality publication?
Because of I can say it. So
what do you mean reduced quality of publication, or?
If I ask why you say about reduction of possibilities for foundation for basic research in Russia. I don't understand. I know that these two biggest scientific foundation in Russia was joined together, but it's not so awful as we are waiting some times ago. The grant is also available.
Yes, I understand. Yes.
And I'm asked about why talk about reduction of possibilities. Okay, I know that people not so interested in discussion in English. It's really difficult for many people, and maybe my English is also not so good, and have a significant problem with this language. But I understand that it's only one way to find new collaboration, new possibilities, and write good articles. Okay, we have some break, about 10 minutes until 2:45 p.m. And in 2:45, we have a presentation of Tatiana Goldina, stands for determining the Fourier tissues resistivity in vivo. Thank you very much. I'm waiting all of you on the next block, and currently we have some breaks. Hello, are you hearing me?
Yes, yes.
Yeah, great. Let's start the next presentation. Tatiana Goydina, stand for determining the Fourier tissues resistivity in vivo. Hello.
Hello, can you hear me?
Yes.
One moment.
Let's start.
Yes. Hello, everyone. My name is Tatiana Goydina. Today, I want you to represent our study about stand for determining the Fourier tissues resistivity in vivo. The stand based on the method of electrical impedance myography. The electrical impedance myography method is considered to solve the problem of anthropomorphic management of rehabilitation medical devices and systems, for example, an upper limb prosthesis. The electrical impedance myography method consists in synchronous registration of the electrical impedance signal and the AMG signal from one system of electrodes. Traditionally, electrical impedance myography studies resistance rather than in vivo resistivity. Resistance is a signal, it can be recorded immediately, but resistivity is a parameter of a mathematical model. To calculate it, it is necessary to solve the inverse problem of identifying the mathematical model parameters. Therefore, it is necessary to develop a methodology and an experimental stand for determining the resistivity of the Fourier tissues based on the results of measuring the electrical resistance on the skin surface in the framework or of an adequate mathematical model. The model of two lower semi-infinity medium involves the separation of the tissues of the Fourier area above which the electrode system is located into two layers: the skin with a specific resistance of ρ1 and a thickness of H, including the epidermis, dermis, and fat, and the muscle with a specific resistance of ρ2. That the process of muscle contraction is influenced by an increase in the specific resistance of muscle, a decrease in the thickness of the skin H. Since the number of unknown parameters of the mathematical model is 3, ρ1, ρ2, and H. Then, to solve the inverse problem, it is necessary that the number of electrode systems is at least 3. It is possible to reduce the number of electrode systems to 2. During the measurement process, a precise effect is performed on the skin to indentation the electrode system from the skin at a distance that is an order of magnitude smaller than the thickness of the skin by 0.1 millimeter. This will allow you to get 4 independent measurements, 2 before indentation and 2 after. Since the process of indentation takes place in the order 0.2 seconds, and the elastin fibers located in the dermis and responsible for the recovery mechanism for small deformation. Two tetrapolar electrode systems have a total of 8 electrodes. The number of electrodes can be reduced to 6 by implementing a single current channel and 2 independent measurement channels as part of a single electrode assembly. To create a precision movement of the electrodes, an experimental stand was assembled. The main components are stepper motor, control unit, guides, electrode system, and hand cradle. Design of the electrode system. The electrode assembly will use 6 electrodes, 2 current and 4 measuring. In fact, these are 2 tetrapolar electrode systems in one, which allow us to perform 2 measurements from 2 channels. When using a needle electrode, for example, a gold contact, with a diameter of 1 millimeter, then the electric field lines are distorted under the electrode. The effect of polarization occurs. An attempt to measure the resistance at point V will be unsuccessful because parasitic capacitors and resistance will have a serious impact. When trying to eliminate the error from the final size of the electrode, the polarization effect appears. The electrode must be both large and small at the same time. This can be achieved as follows. The electrode is made large enough with a diameter of 6 millimeters. It will not distort the field under it. And then a small capillary is made which touches the biological object. Gold-plated electrodes with a diameter of 6 millimeter and a contact surface diameter of 2 millimeter will be used for the measurements. For the research, several bases were developed with different distance between the holes for the electrodes. This was made due to the fact that different patients have different thickness of the skin fat layer. And with increasing distance between the electrodes, the depth of probing also increases. The experiments look like this. An experimental test of the rock of the stand was carried out on a healthy volunteer. The two-channel electrode assembly was located on the forearm at the elbow. The hand was in a relaxed position. The stand was automatically indentation by 0.15 millimeters and returned to the starting position after 1 second. The characteristics changed in the electrical impedance due to the indentation on both channels were about 100 milliohms. There were no volatiles of the electrode skin contact. Two inverse problem was solved for a two-layer medium with different pressing of the electrode system. The first, when the electrode system is tightly pressed, the tissue behaves like a homogeneous medium. There are no differences between two layers, skin and muscle. When the electrode system is on the surface of the skin, you can estimate the specific resistance of the relaxed muscle and the skin fat layer. When the muscle remains tense and the electrode system is tightly pressed, the tissues behave like a homogeneous medium. When muscle remains tense and the electrode system is moving on the surface of the skin, you can estimate the specific resistance of contact muscle. Results. The developed stand makes it possible to extract minor effects of the thickness of the epidermis without disturbing the electrode skin contact. The experimental data obtained before and after indentation allows us to find 3 unknown parameters using only one electrode assembly of 6 electrodes. The result obtained will contribute to improving the stability of the algorithm for solving the inverse problem. Thank you for your attention.
Thank you very much. I waiting questions from other participants. Okay, one question from me.
I have a question.
Please,
yeah.
please.
Excuse me for interrupting you. Tatiana, would you mind telling me, I'm curious, how do you decouple into 2 separate channels the 2 measuring systems in one electrode system? I mean, on a hardware level, how do you decouple them? Well, not to, so that both channels would not interfere with each other.
You mean how we get 2 measurements from one electrode system?
I mean, when you have 2 channels in one electrode system on yes. one PCB on one board, yeah, in one electrode system, it is inevitable that you get interference from one channel to another. And the question is, how do you avoid this interference? When, for example, in one channel, you get an increase in amplitude so that in other, which is isolated, should be isolated, you don't get that. You don't get that increase in amplitude.
We have two channels, yes, and one channel is current, and second channel is potential. And this channel don't
interfere.
You have several electrodes on hardware which not shielded from each other, and if you use, it's very important what's how you design your amplifier, because in sometimes amplifier significantly influences on result, and also we interested what's happened with shielding and. Because it's only your usual chord without upper. I don't know how it's English, upper protection.
The casing, you mean the enclosure?
Yes, yes.
If we have two current channel, yes, it will be problem, but we have only one current channel, and this is not influence on the measurement.
Okay, I see.
Okay, thank you, but we don't disagree. We can't agree with you. Yeah, I suppose. Okay, one question from me. I'm interested. What do you think on mathematical level? I see that 11th slide show signals without filtering of 50 Hz noise, and also you have slopes after plateau, and I see some trends in data because you left side little bit upper than right side of signals. What do you see on processing level, and how you formulate your inverse problem in mathematical terms?
The inverse problem is to find unknown parameters of biological object, and to make some measure of resistivity biological model, and find unknown parameters ρ1, ρ2, and h. This is an inverse problem, and now it is
do you have some matrix or
no?
Okay, thank you. Thank you very much for detailed presentation, because it's really one of the better presentation for this day from my point of view, because you write all steps of your process from hardware to processing level, and it help us clearly understand what you really do, and criticize you better and understand each stage. It's really great. Okay, thank you very much. The next presentation is Anastasia Parnovskaya, evaluation of the 4-arm electroimpedance myography formation mechanism based on physical modeling.
Good afternoon. Excuse me, should I demonstrate the presentation, or do you have this?
Sorry?
Should I demonstrate the screen with my presentation, or do you have it?
You can demonstrate. Unfortunately, A little bit. Yeah, of course. Yeah. Thank you. I suppose something goes wrong. Yes, because you can't start before.
So, do you see the presentation?
Yes, of course. It's good.
Okay.
But maybe you open it on full screen. Could you open it for full screen?
It's opened for me on full screen.
Okay, but for us it's open on only on.
Okay. I don't know how to fix it, so allow me to start my presentation. Defining the type and the parameters of performed action is the key task for control systems for bionic devices, such as bioelectric prostheses, orthoses, and exoskeletons and surgical apparatus. The electromagnetic signal has shown its effectiveness in recognizing actions and basic hand movements. The method of electroimpedance registration for bionic control consists of positioning the system of current and measuring electrodes in the projection area of active muscles. Muscle contraction results to the change in the electrical impedance value. However, to effectively address the challenges of bionic control using electroimpedance, it's important to take into account the dependence of the signal on a number of parameters, which can lead to incorrect interpretation and errors in device control. The study on the parameters underlying the formation mechanisms will potentially allow to bring new opportunities and approaches to biocontrol challenges. Modeling allows to overcome the limitations associated with the experimental estimation of such parameters and get closer to understanding the process of signal generation. To study the morphological changes in the forearm during action performance, magnetic resonance images obtained from 3 volunteers were obtained and analyzed. For each volunteer, 3 series of MRI images were obtained corresponding to 3 wrist positions: neutral, flexion, and extension. To study the morphological changes in the forearm that occur during action performance, magnetic these magnetic resonance images were distinguished by the skin fat, muscle, and bone layers and quantified using the spline function. Mean values of the skin fat, muscle, and thickness were determined, as well as their changes during muscle contraction. With the obtained data, the cylindrical models of the forearm were constructed. Electrodes were assumed to be equidistant from each other by a distance that varied in simulation. Muscle contraction was modeled by changing resistivity of the muscle and by reducing the thickness of a skin fat layer. Simulation results allowed to compare the contribution of different signal formation mechanisms in relation to the selected inter-electrode distances. With an increase in inter-electrode distance, of inter-electrode distance, the current path through the skin fat layer decreases, and the contribution of the muscle resistivity to the signal increases. The opposite effect of the skin fat and muscle layers on the resulting signal determines the importance of selecting the design parameters of electrode system depending on the measurement purpose. The simulation allows to determine the effective inter-electrode distances to maximize the sensitivity of electrical impedance to changes of the skin fat layer thickness and resistivity of muscle tissue. In order to take into account the changes in muscle morphology that occur during action performance, anatomical cross-sectional models of the forearm were constructed from obtained MRI scans. The model considered only skin fat, muscle, and bone layers. It was assumed that all layers have isotropic properties. Electrodes were arranged according to tetrapolate system and were assumed to be identical and equidistant from each other by a distance that varied in simulation. Different placement of registration channels was modeled by electrode system rotation. The results shown on the slide allow to compare the simulated values of electric impedance change for the case when muscle contraction was modeled exclusively by changing the forearm morphology, and for the case that also takes into account the change in the resistivity of the muscle. At small inter-electrode distances, the greatest contribution to the signal is made by the skin fat layer, so the simulated values of the electrical impedance for both cases differ insignificantly. With an increase in the inter-electrode distance, the influence of muscle resistivity is growing. The results obtained from these anatomical models demonstrate a more complex and uncertain dependency than the cylindrical model and indicate the need for an individually oriented approach for choosing the placement location and parameters for electrode systems for control tasks. As the result, an approach to modeling the mechanisms of electroimpedance myography formation is proposed, and physical models are developed to assess their contribution to the resulting signal. The opposite effect of the skin fat and muscle layers determines the importance of selecting the design parameters of electrode system depending on measurement purpose. Difference in the patterns of electroimpedance myography for volunteers indicates the need for an individually oriented approach for choosing the placement location and parameters of electrode system for control tasks. Thank you for your attention. I will be glad to answer your questions.
Okay, thank you very much. I see that electroimpedance becomes more popular in Russia, and it's very good. Maybe the previous speaker can ask questions about these results. And
can I?
Yes, of course. Yeah.
Speaker. Please, how you estimate the specific resistance in muscle?
The chosen parameters for modeling were chosen based on the literature values. It's the mean literature values because in the scientific studies there a range of the parameters. They're not like a signal concrete certain value of it.
And how you evaluate sensitivity about these parameters to your results, or you will not done with? Is it clear or not?
No, can you please repeat the question?
Okay, the results of your modeling depend on the parameters system. Yes?
Yes. Yes.
And will your sensitivity of your results to these parameters? Specific resistance.
In this particular study, we didn't consider the influence of the model parameters such as, for example, the chosen resistivities, how they influence the resulting values, because we didn't consider the modeling of determination the absolute values of the impedance change for the forum for the registration channels. The aim was to study the different mechanisms of signal formation, such as changing of the resistivity of the massa, and we know approximately the value of its change. It's 10%. And also we take into consideration the changing of the skin fat layer thickness that was evaluated by the MRI scans of the volunteers that we've analyzed. So we learned about the main dependency of the signal change with the muscle contraction that was modeled. We didn't try to evaluate the absolute values of it. So maybe with the different resistivities, the results will be insignificantly different. Have I answered your question?
Okay. Thanks for your answer.
Okay, thank you. I also have one question. How much patients was tested in with your device? It's because you show only one images, and maybe this result becomes better or worse in case of other humans. Especially, I'm interested in people with significant thick of subskin fat layer.
Thank you for the question. We've investigated the MRI of 3 volunteers. It's not enough, but we faced some difficulties with the contrast of MRI scans that we have obtained, and the segmentation was done manually. So even for 3 volunteers, it's a lot of work. For the these 3 participants, the main dependency that we investigated, the influence of the intra-electrode distance and the contribution of skin fat and muscle layers on in the relation to these intra-electrode distances is the same. But if we will compare the pattern of impedance change on each registration channel, they were different for different volunteers, and that, as I mentioned, indicates the need for individually oriented approach for choosing the placement location, but not for the actual parameters. They are pretty much the same. Will be.
Thank you very much. The next presentation, model-based assessment of branchial artery diameter from electrical impedance measurements. Mugeb Al-Harosh. Hello.
Thank you very much. I am here. Okay, do you hear me, please? Do you hear me?
Yes.
Is it clear?
Yes.
Okay, I will switch the camera in order to increase the resolution here. I will keep just only the sound, and I will share my screen with you in a few seconds. Okay, here, is it clear?
Yes, we see your presentation.
Okay, let's go. Okay, I am Al-Harosh Mujib, and my study is about model-based assessment of brachial artery diameter from electrical impedance measurement. This is the first step to develop a wearable, non-invasive, cuffless blood pressure monitoring system. High blood pressure is principal indicator of several cardiovascular disorders, including hypertension. However, Blood pressure monitoring and management are essential to provide more effective care to patients and avoid large financial tolls and reduce the fatality of cardiovascular disorders. Several non-invasive methods for continuous blood pressure measuring, including photoplethysmography, tonometry, and ultrasound techniques can be used, but they suffer from a number of technical problems. In particular, photoplethysmography is not suitable for obese people and depends on the temperature and humidity. In turn, ultrasound equipment is too large, which is a disadvantage of using this technology as a device for daily blood pressure monitoring. Considering that the blood, let me go to the next slide. Considering that the blood pressure is in clear correlations with artery diameter change, however, it is suggested that the technique that relies on the assessment of diameter artery waveform changes could give more accurate measurement in comparison with the method that measure the blood pressure by detecting the limb volume changes. The proposed method, as shown here, based on eliminating the artery with small electrode system, which should be positioned above the desired blood vessels. However, to improve the accuracy of measuring the diameter changes, it is necessary to take into the account a number of facts, such as the change of tissue blood filling around the artery, the displacement of the artery itself, and the impact of red blood cell orientation. In order to minimize the effect of surrounding tissues blood flow, small electrode system as shown here with these parameters and with high requirement position regarding the artery is important in this task. The challenge remains due to the impact of red blood cell orientation on impedance waveform, which is the subject of this paper. Numerical modeling based on real data from patient has been developed in order to separate the two mechanisms of electrical impedance changes. That means the diameter changes and the red cell orientation effect. Geometrical model has been designed using COMSOL multiphysics and the geometrical model parameters such as the depth and layer thickness of tissues in the region of interest have been chosen from prior information obtained using ultrasound system. And the tables here, table 1, show the electrophysiological parameters of these tissues correspondingly. Okay, the resistivity of blood has been shown to be velocity dependent due to changes in the orientation of red blood cells induced by changing shear forces during flow. However, in order to estimate the orientation effect on the bioimpedance signal, the following equation was used. The cross-sectional velocity was found using ultrasound. And as a result of this calculation, the orientation effect was estimated. Simultaneously, so as we can see here, simultaneously, electrical impedance mapping of elbow joint area has been obtained, and just the electrical impedance signal from brachial artery position has been selected for the further study as shown in figure 9. As discussed earlier, this signal comprises two components or two mechanisms, which leads to electrical impedance decrease, the diameter changing of brachial artery, and the red cell orientation effect. So subtraction this value, which is near to 17%, as was estimated using the earlier equations, the change of diameter which correspond to the change of blood pressure was estimated, which is in our study is 6%, which is normal for a normal patients with a normal blood pressure. So as we can calculate here, as a result of our study, new method for blood pressure is proposed, which is based on artery diameter changes. This theory will be used for further designing of blood pressure monitoring system. Thank you.
Okay, questions, please. Dear friends, many of us working with impedance and no one questions. I don't believe this. Okay, one question from me for beginning, but I'm also waiting some questions from others, other researcher. You show that this device installed on arm of the human. Could you show some statistics or how your results changes between patients and between? Yep.
We have no more statistics here. We approve our our experiment just only with one patient who have just only ultrasound images, and according to this data, we build a personalized mathematical model based on Council multiphysics. We applied all this data, and just only we get our result from just only one volunteer, one subject, and even this is not a patient with hypertension.
Okay, thank you very much. Questions, please. Okay, no questions. The next presentation is Alexey Tikhomirov, comparison of elliptical and spherical geometric model of the heart for multi-channel for computer multi-channel electrical impedance cardiography.
Yes, thank you. Hello, I sent in for Alexey. I'm a co-author. My name is Arman Petrusyans. Let me just quickly share the screen and we can start. Can you see the PowerPoint presentation? Okay. So let me start. Nowadays, according to World Health Organization, more than 50% of human deaths are caused by heart diseases. It is not great, and we are trying to somehow improve the situation and focus on cardiac stroke volume monitoring. The stroke volume correlates with cardiac function and is used in different cases to determine changes in mechanical heart activity, for example, after myocardial infarction. So there are several non-invasive approaches as well as invasive approaches to calculate this parameter. So for non-invasive, there are CT, ultrasound, MRI, and electrical impedance methods. CT, MRI, and ultrasound, being classical methods, provide high resolution, high spatial resolution, and could give a precise stroke volume value compared to impedance methods. However, the electrical impedance methods, they can be used for continuous monitoring, unlike these precision methods, but the electrical impedance methods lack spatial resolution. These methods could be divided into three main categories. One of which is electrical impedance tomography, which is widely used for lung activity monitoring. And there are also some studies which describe the usage of this method for heart stroke volume calculation. Currently, it's not used in such way because of low spatial resolution and complexity of thoracic map reconstruction. There is also impedance cardiography method, and it, unlike EIT, uses only one channel. However, the empirical ratio for stroke volume calculation is not robust when trying to apply to patients with cardiac diseases. Our solution is multi-channel electrical impedance computer cardiography. The device, the anticipated device, uses only 6 channels, not 16, not 32 like in EIT, not 1 like in ICG. And it also utilizes a mathematical model for the initial state of the patient. On the slide, you may see electrode system placement of the heart, except one, which is used to calculate soft tissue blood pulse filling, which is F. In previous studies, mathematical models based on Lagrange polynomial were used. Base impedance is a function of 7 particular model parameters. But there is a limitation of this mathematical model in a spherical approximation of the heart, because there are only 2 layers and a semi-infinite chest space. This work, however, introduces the elliptical model and compares its performance against a sphere and a real geometry. So an elliptical model has more parameters to describe the position and orientation unambiguously. Instead of just 1 R, it has dA, dB, and dC, which are like half axis of the ellipsoid, and there are also roll, pitch, and yaw angles to describe the orientation. This unambiguous position of a more parameterized model allows to get more precise information. However, there is a trade-off, and the trade-off is that more electrode systems are required per frame for an inverse problem solution. Like a simpler model, a spherical model, on the other hand, requires less electrodes because it has less parameters, but fewer parameters. But it is more restricted in terms of precision and capabilities. But both models utilize electrode placement along heart's short and long axis, as shown on the slide for channels 1 to 5. Okay, so geometric parameters of models were acquired in the study through CT scans of a healthy volunteer. Multispiral computed tomography was carried out in Pirogov Moscow City Clinical Hospital using Toshiba Quillian Prime 160 machine. 3D segmentation was performed with Biomedical software to reconstruct the SCL model of heart chamber's blood. Other software used in this study includes MATLAB, Wolfram Mathematica, COMSOL Multiphysics, and Autodesk NetFab. The study showed that atrial ventricular and anteroatrial ventricular septa form specific data points that interfere with approximation results by forming additional mesh edges, like shown in here, which in turn increases the mean deviation of model surface from the outer layer of the 3D model of the blood inside chambers. So to mitigate this effect, septa and other cavities inside this model needed to be filled in the initial 3D model acquired from Biomedical software. To do so, the first step is to decompose this 3D model into a series of 2D slices. We've done that with Wolfram Mathematica. The slices were made parallel to XY plane, and so all the slices are parallel to each other, obviously. Then for each slide, an envelope was constructed with a tangent path reversal with a rolling circle of a radius of, like here specifically, 20 millimeters, which is shown here in red. The technique allows to pass for an outline for each 2D slice, which is then uniformly filled. And this procedure, as a bonus, not only eliminates the cavities, but it also performs a smoothing. So then the array of these 2D slices merged into a whole 3D voxel model, as shown here. And the newly acquired 3D model is then meshed with a mesh. Vertices of this mesh are then passed to an approximation algorithm to find the closest ellipsoid and sphere, utilizing mean square distance minimization between vertices and the surface of a sphere or an ellipsoid. Okay, so in the study, we've investigated a number of parameters, specifically a volume of the blood, a change in volume over time, over time during a hard cycle, and a displacement of the center of mass in 3 Cartesian directions, x, y, and z. And we've done that for 3 different models, the spherical model, elliptical, and a real 3D geometry. All the horizontal axes on the slide represent an R2R cardiac cycle. So an analysis of center of mass displacements in these 3 plots shown shows that the elliptical model behaves really closely to the real geometry, both by shape and numerically. A spherical model, on the other hand, only has a corresponding shape with numerical values of amplitudes being offset from the real 3D geometry. Model's volumes study, as shown here, revealed that ellipsoid's volume is off only by 3 to 5% on average compared to the real geometry. For a sphere, the offset reaches 12 to 15%, which introduces an error to hemodynamical parameter estimation during the approximation phase of the study. But like, the point of the study is to minimize this effect. So the next phase of a study implies the estimation of the impact of hard chambers blood approximation by a sphere and an ellipsoid on the inverse problem solution, which in this study is assumed to be known. Impedance values were gathered with in silico numerical study using finite element analysis in COMSOL multiphysics. So the electrode system dimension across 2 current electrodes was varied from 80 to 240 millimeters. Resistivity values at 100 kilohertz used in our paper are shown in the table. 1.35 ohm meter for blood, and the soft tissues assumed to be 4.2 ohm meters on average. The averaging of myocardium, other muscles, and lung resistivities is possible since the precordial monitoring across either radial or transverse longitudinal axis studies hard cycles on exhalation, which means that the lung resistivity approaches myocardium resistivity, and then if they can be averaged out to one value. Yes, so the slide shows the results of modeling an electrical impedance over time during the cardiac R2R cycle. The 2 electrode placement schemes were studied along the heart axis, which are upper 3 plots, and the tangent to the heart axis, which are lower 3 plots. The difference in values at the time points corresponds to 0% to 40% for the cardiac cycle, which is a beginning and the end of the ventricular systole. And for small electrode systems, 80 to 120 millimeters, delta Z for 3D model differs more than 50% for the sphere and only 25 to 30% for an ellipsoid's delta Z. For large electrode systems, 200 to 40 millimeters, delta Z for 3D model differs by only 5 to 10% for a sphere and close to 30% for an ellipsoid. To draw a conclusion, the study shows that for a given volunteer, in this particular case study, an elliptical geometric model of heart blood approximates the heart's real 3D geometry with an error margin of 3 to 5%. This elliptical geometric model is preferable when accessing hemodynamic parameters of the heart. Simultaneously, the electrical impedance modeling showed that when using small electrode systems, it is preferable to use an elliptical geometric model. On the other hand, when studying using large electrode systems, it is preferable to use a spherical geometric model. And since electrode systems with sizes over 180 millimeters are usually used for precordial longitudinal transverse mapping, it is necessary to use a spherical mathematical model, which is proven in the study. And the drawn conclusions, as I've said, are valid for this volunteer. And so there are undergoing studies right now on 3 more healthy volunteers, which with perspective on carrying out the study on a larger patient pool, let's say so. Okay, thank you for your attention. I'm ready to answer any of your questions, if any.
Thank you very much. Questions for
Arman.
I have one question.
Yes.
Can the model used to study hertz with some defects, maybe with a ventricular septal defect?
Okay, so we assume that we get the real 3D geometry from a series of CT scans. And for this method to be reliable, there is like basically 2 needs. You can reuse the previous CT images if and only if the constitution of the patient didn't change since the CT images were taken. It can be MRI as well. That's first. And the second, if there are no anatomical morphological changes in the heart. For example, if the patient has got like a myocardial infarction, there are high chances that he or she, they are going to get new CT or MRI sequence, and these new images can be like reused for the purposes of this particular method. So yes, we need like fresh series of scans. If there are any morphological changes, like you can't carry out this unless you have a morphology of given patient.
Okay, dear friends, any questions more? Okay, one question from me. You solve inverse problem, and I want to look at description of mathematical description of problem, and what do you do, how you regularize your problem?
Okay, so as I've said, in this particular study, we assume that the solution is known, but generally the inverse problem here is to reconstruct the change in volume depending on the change in impedance and the base impedance. So the inverse problem, as shown here on this slide at the lower side, is like a Z, an impedance, is a function of resistivities and geometric properties. And to get the inverse problem, the inverse problem is like delta R, which is like you can recalculate the differences in changes of heart's geometric properties when it contracts and expands. And the point is to reconstruct it from delta Z. And delta Z is gathered here. So the inverse problem is delta R, like for a sphere is like only one delta R. For an ellipsoid is delta A, delta B, and delta C, which are then used to calculate delta V. And these geometric properties, like linear sizes, they depend on, they are a function of base impedance, change of impedance, resistivities, and the base geometric properties of the model. So that's how we form the inverse problem. To regularize it, we obviously use we use base assumptions. We have the geometric model. Yes, and as I've said, it is more difficult to regularize the problem for ellipsoid, so we need more parameters. So there is that. But really, this study was not about studying the inverse problem. It was about approximating the behavior, the geometrical changes in the impact of geometric change of hearts, of volume of hearts on the impedance readings. So we solved a different scientific problem here.
Okay, in any case, I will be very glad to see final paper with comparison of your inverse problem solution with other technique.
Yeah, of course, that's like we are approaching that, but before that, we really need to figure out which are impact factors. We need to take into account like every like Mujib said in the previous in previous speech, there are like loads of different parameters that can affect the impedance, and particularly here we researched the geometric impact, but after we've done everything, we can then merge all these studies into one big, and to really check out how the stroke volume approximation with impedance methods, is it viable, is it not viable?
Okay, thank you. I attach one of my last work about simulation of cardiac electrocardiogram. Maybe you found something interesting for your studies, because you also use direct simulation from cardiac to for evaluation electrical impedance methods and other stuff. Maybe you found something interesting for you and for your research group, because I know that you take participation in this conference each year. Yes.
Yeah.
Yes.
I've been here last year. Yeah.
Yeah. Thank you very much. Okay, we have sometimes we have some breaks in time until 4:15 p.m. But I propose to discuss some topics. This block is contains presentations about electrical impedance, and I encourage you to start discussion of different topics. For example, I'm noticed that our people use different hardware devices with different facilities, and use different approach to filter signals and record signals from multi-channel systems. What do you think about? It's not Arman. It's not a question for you, but it's a question for any people who stay here. I encourage you to turn on camera and discuss about different topics. What is necessary hardware properties for good or perfect research in electroimpedance methods from your point of view?
Well, first of all, the potential currents, the potential channels must have a very big inputs impedance in amounts of giga ohms, just to be sure that there are no interferences from the changes of body to electrode connection resistance, which is can really mess up the readings, especially when there are some dynamic readings, for example, like in moving forearm. Yes, as we've seen today. So there is that. But
dear colleagues, do you have some opinions about these points? Maybe somebody stay in conference and active and want to discuss some ideas, some methods. We have some discussion before about shielding and about problems with multi-channel system, because when many channels goes each other, values interfere between each other, and it's lead to some problems. It's require more complex amplifiers and other stuffs.
Yes, but you can carry out this even with simpler amplifiers, given that the channels are separated electrically. In an ideal case, you should have same power values for both of channels, but they should be detached from one another, so that they need to be galvanically unattached. So that's not like you connect one amplifier to the wall socket and then another to the same wall socket. You need to separate them, but you need to have the same values, because if you have different powers on operating amplifiers, which can be like really the same in both channels, that can mess up the readings as well. So it can be the simplest amplifier at all time. The important stuff is for them to be disattached from each other from electrical point of view. So no capacitance between them, no inductance between them. What else colleagues could add? Really struggling here.
Okay, thank you very much. I see that other people don't interest in discussion. For this reason, I turn on break thumbnails, and we return to the last block of this section in 4 p.m. and 15 minutes. Yes, 4:15 p.m. Thank you very much. We are waiting you on the last block, and have a good day. And sorry. Yeah. Thank you very much.
Thank you.
Hello.
Hello.
Are you hear me?
Yes,
Thank you very much. I'm glad to see you, you all here. This is the last block of our section and the ending of our conference. And currently we are waiting presentation from Inna Stepanova, hand skin temperature after local cold test, thermal imaging observation, and mathematical computation. Okay, let's start. We are waiting questions from other colleagues after the presentation.
Excuse me, dear colleagues, 1 minute, please. Let me introduce our contribution named
Excuse me, we can't see you. We can't see your presentation. You switch off the screen share. Could you please share the screen again?
It's okay. Can you see my contribution?
Yes, thank you very much. Thank you.
Excuse me, dear colleagues. Let me introduce a speech, hand skin temperature after a local cold test, thermal imaging observation to mathematical computation. The hand skin temperature correlates well with physiological state of the organism, and it was shown to be a sensitive marker of impaired adaptation. The main factor that determines the temperature of organs of a living organism is the level of tissue blood flow. Infrared thermography is a proven method for the non-contact determination of body surface temperature. It's found in our study that a decrease or increase in tissue blood flow depends on the corresponding decreasing or increasing in the skin surface temperature. Almost all biological parameters and phenomena, including blood flow, have an oscillatory nature. The calculated frequencies and periods of fluctuations in the level of blood flow are shown on this slide, on this picture. The aim of our work is a thermographic study of the body's response to a cold test with the identification of oscillatory phenomena in the temperature of characteristic areas of the body surface. The experiment involved 48 healthy volunteers. Cooling was carried out by immersing hand of one arm in cold water with 15 degrees for 1 minute. A thermal imager was used to measure the temperature. The palm of both hands were fixed on one thermogram. The average temperature from the palm area of the bare hand was calculated. On this slide it is shown. Figure shows a typical observation of the palm temperature dynamics. It was found then in half of the cases the temperature of the uncooled hand decreased by the time the temperature of both became equal. Starting from some time, the temperature fluctuations of the cooled and uncooled palms were synchronized. On the picture it is shown, please see. A histogram on this slide shows the percentage ratio of the recovery time of the temperature of a cooled hand for male and female testes. The recovery time was considered to be the time of the greatest deceleration of the temperature change. The average value of the temperature recovery time of the hand was approximately 50 minutes regardless of gender. The deviation from the mean upward and downward can be explained by individual differences in the metabolic rate of the participants in the experiment. Discussion. Other authors have shown that there were dilatations of microvessels above at increase and decrease in the surface temperature of the skin. This effect can explain a slight increase in the temperature of the uncooled palm and the initial stage of the restoration in the temperature of the chilled hand. In figure, it was during the first 7 minutes. A mirror, a so-called mirror effect, as a decrease in skin temperature of an unstimulated hand was observed in half of the cases in our and other studies. This figure also shows that the process of recovering the temperature of a chilled hand is oscillatory, and I should stress this fact. Fluctuations in temperature values also occur in an uncooled hand, which was observed in all tests. Let's description of mathematical computations. To calculate the positive periods of the observed fluctuations, a spectral analysis of the thermographic data was performed. This spectral analysis was performed within the framework of the so-called linear integral representation methods. We have a great experience in implementing these methods for solving linear and also non-linear problems in geophysics and geomorphology. And now we tried to implement this technique for building analytical approximation of the thermal fields of the surface body temperature, and also to fulfill the spectral analysis. The applied method also allows one to draw conclusions about the temperature field itself. The Fourier transform was proposed at the corresponding linear integral representation representations. Strachov's method is supplemented by an improved block contrast method based on the previously developed block coordinate descent method, modified for the one-dimensional case. And this slide shows we consider a linear algebraic equation system. It's a signal to be processed. It's a matrix, usually bad conditioned or ill conditioned. Lambda is a vector for known parameters. The proposed computer technologies for contrasting constructing analytical data approximation are as follows. Initially, the elements of matrix are formed. Next, a stable approximate solution to the system of linear algebraic equation system is found using the block coordinate descent method. The essence of the block coordinate descent method is that the matrix A, respectively the vector X or lambda, as I stressed before, in the original system, are represented in block form. In the improved block contrast method, we solve the problem of finding a stable approximate solution to a system of linear algebraic equations by using the free layer improved Chebyshev iterative method for each of the blocks, or by regularizing of the Cholesky method. Computations. Finally, the values of the periods are calculated using the values of the real and imaginary parts of the complex Fourier transform spectrum, or complex Fourier transform, and the values of the components of the Lagrange multipliers vector. As a result of the calculations, the spectral amplitudes of the possible vibration frequencies were calculated. We see the predominance of the 1 minute period, 1 minute periods on the diagram. Please see. The the number of falling out of periods of 1 minute for a cooled hand is significantly less than for an uncooled hand. For the cooled test, the number of manifestations of periods with a duration of 2, 3, 3.5, 7 minutes, and 8.5 minutes increased. In that way, the probability of their presence in the walk of the circulatory vascular system has increased. Such changes may indicate a restructuring of the walk of the circulatory vascular system during a cold test. The calculated periods of 1 to 1.5 minutes can be attributed to the range of the no-dependent endothelial activity, nitric oxide, no-dependent, and from 2 minutes to 3.5 minutes to the range of no-independent endothelial activity. It follows from our calculations that there may be other periods of temperature fluctuations, It was discovered circumferential and body temperature. There were discovered circumferential and body temperature oscillations in 10 to 120 minutes range. Due to the coincides of periods, they may reflect the effect of some external environmental biotropic factor and ultraradian rhythms, which are important to the adaptation of organism to a challenge. So we can accept the real presence of periods of fluctuations in the human body temperature lasting more than 10 minutes, the presence of which is indicated by our calculations. However, the specific physiological reasons for the observed and calculated oscillatory phenomena should be considered insufficiently studied yet. Conclusion. Let me to conclude. In accordance with the set goal, measurements of the dynamics of temperature fields were carried out with the simplest cold test carried out on 48 testes of different sex and age. Oscillatory phenomena in the temperature response of the body were found, which were observed in all testes regardless of gender and age. The difference was integral relaxation times, which varied from 20 to 60 minutes. A mathematical model based on the method of linear integral representation, supplemented by an improved method of block contrast, modified for the one-dimensional case, is proposed in our contribution. As a result of the calculations, the spectral amplitudes of possible periods of oscillation were calculated, which showed a quantitative agreement with the experimental results and revealed additional longer periods of temperature fluctuations that were not observed in our measurements but correspond to the literature data. Possible physiological mechanisms described in the literature explaining the measured and calculated oscillatory phenomena are presented. Our task for the future is to improve the computational model and establish a connection between our results with clinical studies. And these are to analyze, to study the thermal fields of the skin temperature. Our method allows us to build analytical continuations of signals to be processed. Signals may have nature. Thank you for attention.
Thank you very much. Questions, please? I have one question about the data. How much patients provide data for your study?
There were 48 volunteers of different age and gender. About 1/2 of this group was were women, and 1/2 were men.
Have you performed statistical tests or statistical analysis for your results?
No, our method is does not imply any statistical analysis. This method is fulfilled within the framework of a deterministic approach, the linear integral representation method. This method allows us to solve a great variety of inverse problems in various areas of science. It is not a statistical; it's a statistical method. We have built an analytical approximations of a thermal field, and also we have fulfilled spectral analysis.
Thank you for your study and for your presentation. I ask the following speaker, Denis Lapitan, influence of the digital filter bandwidth on the photoprismographic waveforms. Okay, who presents this? Who presents the next presentation? Okay, we will wait 2 minutes. 2 minutes. Maybe we have problem with connection.
In the meantime, if you don't mind, I have a question for colleagues.
Yes.
There are, in most cases, we use matrix computations to get solutions, but if we need something done in real time, we really need the faster approach. So if you have a problem which implies a real-time solution, for example, 100 milliseconds per frame, or more or less, what's your go-to method to increase the computational efficiency per frame? I mean, like, for example, you like in most of inverse problems, you need to calculate huge matrices with up to 100 rows, thousands of columns or whatever, but it can't be done effectively in a magnitude of seconds. So what is your approach to that, if you've given any thoughts on this topic? For example, one of the problems I tried to solve earlier is to reconstruct an electrical impedance tomography image in viable amounts of time, so the time per frame would be less than a characteristic time of some physiological changes that can occur between
I'm
frames.
sorry, from my point of view, the previous speaker is disabled from Zoom. She's not in the list of participants now. Unfortunately, we can repeat this question if she reconnect to us. Also, I write organizer committee about missing speaker, and they try to call him. And now I ask Andrei Sherbachev, could you start your presentation? Your presentation is third in this section.
Yes, can you hear me?
Yeah, good. Let's start.
Okay, thank you. Oh, you see my screen?
Yes.
So let's start my presentation. So good day, everyone. My presentation is about determination of electrode assembly parameters for electroimpedance measurement of artificial heart ventricles volume. Let's start with the problem overview. Cardiovascular disease is the leading cause of death worldwide. According to the World Health Organization, about 80 million people died from it in last year. Many of these deaths are due to heart failure and stroke. In Russia, cardiovascular disease remains a national problem. Every 30th citizen of Russian Federation suffers from cardiovascular pathology. There is no doubt that cardiac transplantation is called the gold standard. It is the only effective treatment for now. However, there is a serious shortage of donor organs. It's impossible to provide all those in need a heart transplantation. The average waiting time exceeds 2 years. Therefore, in recent decades, method of mechanical blood circulation support, called MBCS, have been developed and introduced into clinical practice to treat patients. MBCS is especially relevant for patients on a waiting list and can be produced by heart transplantation due to lack of a donor organ. The development of new MBCS devices is an important task of modern biomedical engineering. Ventricle assist device, also called VAD, it's an implantable mechanical pump that helps your heart pump blood. It's used particularly or completely replace the function of a failing heart. VADs are designed to assist right ventricle called RVAD, or for left ventricle called LVAD, or assist both ventricles called BVAD. It's been intensively developed for treatment of patients with terminal forms of cardiac disease, also called TCD. In process development new MBCS system, one of the main stage is to conduct research with allowing to evaluate the efficiency of pump both in normal condition and in simulating TCD. For successful conduct of such tests, now based on Shumakov Center for Transplantology and Artificial Organs and the Faculty of Biomedical Technology, Bauman Moscow State Technical University, is developing an artificial heart ventricle control system. The electrode assembly for electroimpedance measurement described in this paper is an important part of the system being developed. Applying the geometry of the MEDOS artificial ventricle, the location of various electrode assemblies is inside heart is modeled. The ANSYS software was chosen as simulating environment. This software has many libraries, including the ICDC library, which will be used in study of the model. The body of artificial heart ventricle is constituted as a silicone casing in a form of two hemispheres. A silicone membrane is located in the middle of casing. The air fills hemisphere above the membrane. The water-side solution is used as a working fluid. The electrodes are made of stainless steel. The parameters of the probing signal we chosen as the following. The current amplitude 1 milliampere, the frequency of probing current 100 kilohertz. As air enters the upper section, the membrane moves and the volume of liquid under membrane changes. To simulate this process, 6 positions of the artificial heart ventricle membrane were considered. It's 3, 8, 20 millimeters from the wall with noseless, 50 millimeters it's a central position, and 27 millimeters from the back wall with noseless. So to measure the volume of the ventricle of artificial heart, the electrical impedance must be calculated of the domain throughout which current flow experiences. An electrode assembly is used as a current source and as a voltage meter. Bipolar and tetrapolar electrode system are distinguished. In bipolar system, 2 electrodes are used both to pass and to measure electrode. In tetrapolar measurement, 4 electrodes are used, 2 which are current passing and 2 others are measuring. Due to low expected interfacial impedance and the limit size of the internal chamber, a bipolar electrode system was initially considered. To evaluate the performance of different assembly options, it's proposed to calculate the potential difference between the measuring electrode and the current density. Those data obtained show the tetrapolar technique is much more sensitive to changes in membrane position, with distinction between circuits continues up 14 times. The next step is define the geometric parameters of electrode assembly. The distance between the measuring electrodes and the distance of current electrodes and electrode radius must be determined. All electrodes are mounted symmetrically in pairs, one plane passing through the middle of ventricle. The distance between the electrodes is measured from their centers. The distance between the measuring electrodes is initially determined. When designed a real electrode assembly, one of the select parameters is the radius of the electrodes. We're simulating the electrodes with radius ranging from 2 mm to 5 mm with a half millimeter step. So on this slide, you can see a result of simulation. We consider 6 assembly position. It's 15, 22, 29, 36, 43, and 51 millimeter. The calculation of changes of current density and potential difference is carried out. The values obtained during the simulation are shown in the first table. So the next step is determine the distance between current and measuring electrodes in the tetrapolar assembly. It's necessary to locate such position of the current electrodes, which is maximum potential difference in observed the measuring electrodes. When modeling the following options, the location were considered 15, 18, 22, 26, 30, and 34 millimeters. Thus, preferred distance between measuring electrode is 43 millimeters. The distance between the current and measuring electrodes is 15. At this location, the ratio of the distance between the current electrodes and the distance between the measuring electrodes is 0.59, which is closer to 0.6, which is most optimal according to the literate data. From values obtained during the simulation, it can be estimated that the preferred radius of electrode in this assembly is 4 millimeters. The electrode installation diagram in a real artificial heart ventricle is shown on the left side of slide. All studies artificial heart ventricle was driven by pneumatic drive sinus artificial heart free. This assembly complies to current and measuring electrodes located inside artificial heart ventricle water chamber. An example of signal received with a quadrospectrograph at frequency of 100 kHz. It's presented on the right side. This frequency was chosen because it's common used in bioimpedance measurement, and it's open a possibility for future research in vivo studies. Applying the obtained geometric parameters and electrode assembly was made a test after which serious experiments were conducted. the control volumes of liquid inside the chamber were measured for approximation. The following volumes was used. It's 30, 50, 75, 100, 125, 150, 170 millimeters. The data obtained from experiments are shown in the table below. Considering the data in table, it was found out high accuracy of data obtained. The development assembly provides measurement of the volume of liquid inside artificial heart ventricle with an error less than 5%. In view of increasing incidence rate of cardiovascular system, development of new devices for mechanical support of blood circulation is highly relevant. The basic parameters of electrode assembly for continuous liquid volume measurement in artificial heart ventricle were reviewed and validated during research process. The result of computer simulation and experimental testing of electrode system for electroimpedance measurement of volume of artificial heart obtained in the article are great practical significance for development of a biotechnical system for adaptive control of artificial heart ventricles. So thank you very much for your attention. I feel free to ask your questions.
Thank you. Very interesting presentation. We're waiting questions. Maybe some people want to ask
I have
last
a
presenter.
question.
Yes, yes, please.
Yes, please. Do you use in the model the movement of liquid flow, or the liquid is stationary? Is it clear?
Okay, I understand. So in my model, when changing the membrane position in liquid, we don't have any streams or any changes, only change volume of liquid in artificial heart.
And this is a limitation, this is assumption about your model. Is that very important to modeling in future process, or it is lethal effect?
So this model was development to determine parameters of electrode assembly. So we so in data what we have, we can show that this electrode assembly in real test can measure impedance with little error, less than 5%. So for us research, it's very good. And I think we don't modify this model in next research. So this model needs to development electrode assembly, and this assembly correct for our research.
Mm-hmm. But in the real liquid in biological object, the real liquid is blood, yes, and in the blood contained the red blood erythrocyte, and
yes, of course.
And these cells can be influence of influence of the dynamics of liquid, and maybe influence on your results. You will be modified your model or not with this real application, or in your task it's not used.
Okay, I understand the question. So in our test bench, we will use water salt solution. So we don't have blood or
any components of blood. Maybe in next research we will use water salt solution with glycerin. So in current research, we don't work with blood, so these effects will not shown.
Okay, fine.
Also, I noticed that conductivity of blood related to hematocritus parameter.
Yes, but this stent is development for test new mechanical device for mechanical blood circulation. So in at test bench, we in this study we works only with water salt solution. In real blood, of course, have many effects, but in our working fluid, these effects is not shown.
Okay, thank you very much. Currently, we finish our section. Unfortunately, the previous presenter, one of presenter withdrew his article from conference. And for this reason, we finished. Currently, we have time for open discussion, open mind, for new ideas or something. Maybe some people want to say something about organization or about conference, about this section, and what's the best presentation from your point of view. Okay, absolute silence. Okay, in this case, we finished. Thank you very much for participation. Thank you very much for your great presentation, great impact, great results, and we hope that all articles found people who cite these articles, and you gain more citation, more index, and more career, and raise your career with our conference. Thank you very much, and have a good day, and good study for you. Thank you very much.
Thank you, you too.
Thank you. Good luck.